This conference will now be recorded.
Sorry. Okay. I hope now you can hear me. So this is the agenda we are talking about. We'll start with courses, institute overview, understanding electronic systems. We'll talk about VLSI design flow, what is front end domain, what is back end domain. Then we'll talk about uh, what are the different job roles in VLSI domain. Then we'll talk about what is the skill set required. Let's say you want to get into front end domain job. What is the skill set that you require? How do you choose the right domain? Then the institute facilities. We'll talk about how to prepare for the job. Okay. Why career in VLSI and the placements. We'll also discuss any questions you have. Okay. Just about myself. I'm the founder of the institute. I have dual degree from IIT Madras. 11 plus years teaching experience. I've been teaching since 2012. I have around 14 plus years working experience. So I also do some corporate trainings for synopsis and mentor graphics. Let's now talk about the courses starting today. As you are aware, VLSI. As you are aware, VLSI is a big flow. I mean, starting from the specifications till we do the packaging of the product. It goes through almost 15 steps. We offer, as an institute, offer courses in almost everything. Like we offer course in RTL design, RTL verification, RTL integration, physical design, DFT. Almost 8 9 domains we offer training. We don't want to keep a dedicated demo for each and everything. Okay. Rather, what we do is we majorly divide the courses into two categories. One is the front-end domain courses, one is the back-end domain courses. So today's demo session is meant for all the courses falling into front-end domain. Okay. So what are the courses starting today is RTL design and functional verification. This is one course. The same course you can call by different names. We can even call, when we say the course, front end training for freshers. When I say functional verification training for freshers, or even ASIC verification, all these four names are referring to the same course. So there is no difference. The content and the schedule, everything is exactly same. It's just different naming. Then we have a course for experienced engineers also, the functional verification training for experienced engineers. You may say, why does a experienced person requires training? It is the upskilling. Many times what happens, someone who is already working in the industry, he works only in some minor aspects. He doesn't work on the entire flow. So during that time, they need to fill that gap. So this is where this course, functional verification training for experience, will fill that gap, will focus on the advanced aspects of the SV, UVM and the projects. Yeah. SOC verification is a different code. No, no, not. I will show you the content also. See, if your question is about what is covered in, it's a different course. SOC design and verification is different. Debug techniques, these are all different courses. Whereas when it comes to functional verification for experienced engineers, this is the content. System Verilog, in-depth, UVM in-depth, AHP, AHP verification IP, AHP interconnect verification, some USB core verification. These all topics are covered. It doesn't have SOC design and verification. Okay. Also, we are starting today training for Verilog for design and verification, System Verilog for functional verification. Majorly, these two courses are meant for students who are currently pursuing their BTech third year and fourth year. uh, they won't have the time to do entire 7 8 months course, because they'll have their own coursework. Because of that, they can finish this course in 2 months, they can finish this course in 2.5 months. So if they will only have 2 3 months time, right, internship and all that, they can do. Now someone who is already good with Verilog, he can directly start with system Verilog. Someone who is good with digital and he doesn't know Verilog, he can start with Verilog. The advantage is, if a person who is pursuing BTech, currently pursuing BTech, does this. So, if someone who is currently pursuing BTech does this Verilog course, it is not, it will help him gain the expertise with the other programming also. Let's say he can learn, I mean, there is no big difference between C language and Verilog language. If you are good with Verilog, you can easily learn C language also. Someone who is already good with Verilog, he can do system Verilog course. So as I said, these two courses are for the people mostly who are currently pursuing their BTech and MTech, and they have 2 3 months time and they want to do the course. Other than that, today we are also starting a course on FPGA design and verification. We'll talk about FPGA shortly. Then we are starting a course on RTL design and integration. You see, when you talk about front end domain, in VLSI front end domain, majorly four activities are involved. One is called as design architecture, coming up with the design architecture. I mean, what all blocks are required, how they are interconnected, various details. Then RTL coding, that is using Verilog or VHDL languages. This is the second part. The third one would be RTL integration. Integration means putting together small blocks to get a bigger system. Once you have done the RTL integration, you have to do RTL verification. There are majorly four aspects: design architecture, RTL coding, RTL integration, and RTL verification. These steps are kind of common for FPGA also. I mean, whether you take ASIC, whether you take FPGA, they are all common. But then FPGA has different flow for the backend domain. Like in VLSI, we do in ASIC, we do physical design, DFT, static timing analysis. There are multiple things we do. Similar thing is done for FPGA also, but the flow is a bit different compared to ASIC. So hence, we also offer a course on FPGA and RTL design integration. Someone who wants to make a career in design and integration, they go for this courses. Someone who want to make a career in functional verification, they go for this course. Next, DFT, design for testability. These are the courses which we are starting today. Okay, now someone who want to attend DFT course will have a dedicated demo session sometime today or tomorrow. Our admin will inform those who have filled the form for DFT will have a dedicated demo session. I mean, same thing for these three courses. Someone who is interested in FPGA will have another 2 hours of demo session either today or tomorrow. Same thing for design integration, same thing for DFT. So in majorly, I can say there are four courses starting today. One is functional verification related courses, RTL design and integration course. Then we have DFT, FPGA system. But today, whatever I am doing, it is common for everyone. I mean, I'm just giving a quick overview of what is what, because many people who attend this training are the demo session, are the fresh graduates who have just passed out of the college or currently pursuing their final year. So they won't have in-depth idea of what is VLSI, what is embedded systems. So this session is to help you understand that, so that you will be able to make a better decision. First of all, whether should you choose a career in VLSI or should you choose career in embedded systems. In VLSI, what domain you can choose, what are the opportunities, placement opportunities, what is the reality regarding the placements. We'll discuss all that. Demo session is from 9:30 to 12:30, today's schedule. DFT demo or admin will inform. During the DFT technical and FPGA RTL integration, those who are interested, or admin will inform the schedule in the WhatsApp and email. Okay. So this is about the courses that are starting today. Now let us start off with understanding of electronic systems. What is the idea of this electronic system understanding? Is like, as I said, many of you are graduated recently, so I want to give you a decent, a basic overview of what is what in electronic system. You at the end of this slide, you should understand what is VLSI, what is the role of a VLSI engineer, and what is the embedded system, what does an embedded system engineer do. That kind of understanding you should have definitely, because many times it is easy to get confused between VLSI and embedded system. Someone may think embedded system engineer also does VLSI. Okay, so we'll discuss all those aspects. So if you talk about any electronic system, so let's start off with understanding a mobile phone, because it is something that we use day to day. So can you tell me what all things goes into a mobile phone? I mean, for mobile phone to work, what all things are going into the mobile phone? Tell me. Processor, okay. SoC. So first of all, hardware, the entire hardware, the piece what you see is the hardware, right? Is it sufficient for mobile phone to work? All right. For mobile phone to work, just the hardware is not sufficient. What else do you require? You require software. But before software, what do you need? Operating system. Can you use a mobile phone without operating system? Right. Even for operating system to work, you need drivers. Drivers means like we call USB drivers, protocol specific drivers will be there. So there are multiple things are required. Let's summarize what is required. For mobile phone to function properly, we need hardware. So for mobile phone to function properly, we need hardware. Then what else? We need protocol specific drivers. I'll explain what is drivers in some time. Okay, going forward you'll understand that one of the major role of embedded system engineer is to develop those drivers, whatever we are calling USB drivers, PCI Express drivers. The role of a embedded system engineer is to develop those drivers. Third thing is operating system like Android, iOS. Okay, different types of OS is required. Fourth, the applications that work on the software, on the operating system. For example, in my mobile phone, I have WhatsApp, GPay, Google Maps, different apps are there. So this is what you comes to your mind. I mean, when I say mobile phone, it comes only to your mind is hardware. But hardware alone is not sufficient for an electronic system to work. It's not just for mobile phone. Even if you take an example of a laptop, it also requires all these four layers. Our laptop also requires hardware. Laptop also requires drivers, also requires operating system and the applications, the softwares that you install on operating system. Okay. So now let's understand what is what. So what all things are make up a mobile phone hardware? When I say hardware, it's the chips, processor, screen, USB port, camera, multiple things make up the hardware. What is the next one? Then there are things which we don't see. For example, firmware, what we call as drivers, then OS, then the applications. All these four put together is what makes an electronic system. Okay. For that matter, these are all important actually. It's not like only hardware is important, it's not like only software is important or only operating system is important. For it to function properly, everything should be good. Okay. Let's say if I take a very poor quality hardware, okay, my phone hardware is very bad, not good, and you install a very good operating system, very good driver, will it work? Same thing, right? Anything you, everyone, everything has its own importance, right? I may have a very good phone, but my app is very bad, the application that is developed is very bad, then is there any use? No, right? So everything should be good, only then the system works properly. So like if you, in summary, mobile phone has four layers. One is what? Hardware. Who develops hardware? What is that person is called as? The person who develops hardware is called as what? He's called as VLSI engineer. The person who develops hardware is called as VLSI engineer. Now VLSI engineer itself can mean many things. ASIC engineer, FPGA engineer, even who works on PCB engineer. PCB also is a hardware engineer. And someone who works on printed circuit board, that whole manufacturing, he is also a hardware engineer. So majorly, since we are looking at VLSI domain, we are talking about VLSI engineer. You understand what is the role of a hardware engineer? It is to develop the hardware. His role is to develop the hardware. What is the next layer? Firmware. The example of firmwares are various drivers: USB drivers, SATA drivers, SSD drivers. Whenever you connect SSD device into your laptop, let's say, imagine this is my laptop. I connected one SSD device. There is an interaction that happens. There is a communication that happens between this and this, between my laptop and SSD drive, solid state drive. There is a communication happens. For that communication, drivers are required. How those communication should happen, that is coordinated by the drivers. Who develops firmware?
Sir,
Yeah.
sir, so firmware are basically like drivers which helps in communication between hardware and software like that.
Yes.
Okay.
Okay. Who develops firmware? This person is called as embedded systems engineer. Then operating system, Android OS, iOS, Windows, Linux. These are all the examples of operating system. Who develops OS? It's the software engineer. And applications, all the apps in mobile like WhatsApp, GPay, Maps, everything. Who develops? It's either software engineer or app developers. You see, there is a specific job role called as app developers. Okay. These are the four categories. Okay. So we are working on hardware development. So we are VLS engineers. So our responsibility is to develop the hardware. As I said earlier, all four layers are essential for electronic device to work properly. Okay. So we can take a simple analogy to understand an electronic system. Very simple analogy. Imagine a bus with passengers, bus which is having a passengers. There is what all elements are involved in that bus is there. What else is there? Bus is like the hardware. Then you have a driver. Without driver, can bus move? All right. He's like the firmware. In the bus, the driver is a firmware actually, or he's a driver. That's why the name driver came, because he controls the hardware. He controls the bus. Let's say you're sitting in the bus. Can you control the bus? No, right? So any control, who does the control of the bus? Driver. So let's say you want bus to stop. Will you go and apply brake? No, right? You give some indication to him. What indication? Generally in the buses they will give some kind of switch. You press that switch, the indication goes to the driver, then he applies the brake. Same way, you don't directly interface with the hardware. You don't directly work with the bus. You communicate everything through the driver to the hardware. So then you have conductor. Conductor is like operating system. I mean, he takes your messages to the driver. You're sitting in the back of the bus. Even if you shout, it won't. Driver can't listen. You got it right. Even if you shout, driver can't listen because you are sitting in the back of the bus. So whom you will tell? Conductor. So conductor understands. You will tell stop. You see, conductor has different way. He will whistle. No, right? He won't say stop all that. He has his own way. So the point I am trying to tell here is that the way you talk to conductor is different. Way conductor and driver talks to each other is different. Their mode of same thing happens in the electronic systems also. The way communication happens between hardware and firmware, okay, it's different. They are called as drivers. The way communication happens between firmware and operating system, that is the driver and the conductor. Like in whistle mode, they will do to go fast, to slow down, to stop. They have different types of whistles they do. Here also we use something called as APIs, application interface calls. Okay, through that they will do. Okay, then the system calls, they will be, they are different inside. Yeah. API is nothing but the entire set of instructions encapsulated into as one program. Yeah. Yeah. Yes. It's you can say system call is one subset of API. Yeah. What is the fourth thing involved in this? Passengers. So passengers are like the applications. So these are the four layers of the uh, bus in this our example. What is a use case? In a bus, what is the use case? Let's understand. A passenger wants bus to stop. As I said earlier, he will not go and stop the bus. He will not apply the brake. He will tell to whom? Conductor. Intimate the conductor. Then conductor informs driver. Then driver controls the bus to stop the bus. Exactly same thing happens in electronic systems also. Okay, idea is to help you understand what is what. Now you should have a basic idea about what is VLSI, what is embedded system. VLSI engineer is responsible for developing of hardware. Now there are multiple choices. As a hardware engineer, let's say I'm a hardware engineer, I can develop my hardware in ASIC flow, application specific integrated circuit. Second, I can develop the hardware in FPGA flow, field programmable gate array. Third thing is I can use printed circuit boards. There are multiple ways I can develop hardware. Do you understand what is an embedded system engineer does? Okay, they are responsible for developing the firmware. Okay,
Hello, sir.
yeah, please ask.
Sir, these microcontroller based systems, these are categorized under like embedded systems only.
No, no. Again, same thing. Microcontroller things. If let's say if you are working on some Beagle Bone or those kind of hardware, you are doing a role of an embedded system engineer because there are already the hardware is available for you, right? When you buy that Beagle Bone kind of things, already the hardware is available for you. You are doing the role of a firmware or maybe the operating system programming, right? You're programming the behavior of the hardware. Does it answer your
Understood.
question?
Yes, thank you.
Next. So, what is the role of a driver? Let's understand. When USB device is connected to the laptop, you know, right? I mean, you connect to the laptop. What happens at the bottom right corner? Some information will come. Western Digital 1 terabyte SSD is connected. That kind of message will come, right? So that is all done by drivers. So USB device gets detected. We start doing the transfers to the USB device. USB drivers. Driver is nothing but when I say driver, it's a set of assembly instructions, assembly language instructions. Control the USB related hardware behavior. Like for example, in a example of bus, the driver had control of accelerator, brake, clutch, gear, multiple things. Through that, he was able to control the behavior of the bus, right? Whether it will stop, it will go fast, it will slow down, everything. Same way, USB driver is nothing but a assembly instructions, the processor specific instructions. They will be used to control the USB behavior. Whether USB will be transfer will be done, speed change will happen. All the decision making is done as part of the USB driver flow. Embedded system engineer develops these drivers, generally done using embedded C language. The drivers are developed using embedded C language. Eventually, those that is converted into assembly instructions, which will be loaded into the process, I mean memory, and processor executes those instructions. So let's take one more typical scenario in our use case. I think that is there. We'll discuss. Okay, now Does in the case of bus example, does bus driver manufacture the bus? No. That means what? Same way, embedded system engineer won't be working on hardware development. He is only responsible for development of the drivers. He don't have anything to do with Verilog language. He don't have anything to do with system Verilog because he doesn't work on development of the hardware. Embedded system engineer role is to develop the drivers. So this answers one question. Many times student ask, should I choose between VLSI and embedded system? If you are very interested in programming kind of domain job, you can go for embedded system because embedded system will mostly involve programming only, understanding of the protocol and having exposure to the embedded C programming, C language, and develop the drivers. I mean, that is one aspect of embedded system. There are multiple other aspects. Let's take use case of drivers. Yeah.
When we have this at the SOC level, right?
Yeah.
There also we do some kind of a program at the system on chip level.
Yeah.
You can say it's a validation.
Yes.
So can you call it as a embedded system?
No. See, SOC embedded system is anytime your drivers that are going into the SOC, they form the embedded system.
Okay. But it will not go right into the memory, but it is a kind of a set of instructions.
No, actually, every instruction that we execute will be sitting in the memory only. Every instruction that processor has to execute will be part of the process. I'll tell you further. Okay. Is everyone facing issue with my audio?
No, sir.
Okay. So there was one question about drivers, right? I mean, so what happens? First let's go through this one, then I'll explain. Let's say, let's take use case. Current mobile phone screen turn off time is 30 seconds. Generally, what happens? If you don't use for mobile phone for some time, it will go to sleep mode for after 30 seconds or 1 minute based on your setting. I want to change it to 60 seconds. How do you do that? Tell me. Go to the settings, display related settings, and change it to 60. Actually, you know what is happening? Finally, whatever you're changing, the effect is taking at the hardware level. But are you opening the hardware and changing some number there? You're not changing any hardware and changing the number. Okay. So what happens? Let's do it. Let's understand. We open mobile and apply number 60 on the hardware? No, right? We don't write 60 on the hardware. So what we do? You are an application. You shouldn't directly interface with hardware. We are working at application level, so we don't directly interface with hardware. So how we do it? Open the settings, then change it 30 to 60. Change number 30 to 60. This instruction goes to OS. OS conveys this to power management driver. There will be something called as power management driver. That is part of the operating system. Generally, what happens when Windows releases operating system? When Windows releases operating system, it has standard set of drivers that are already part of it. Okay. Sometimes if it is not there, user can also install the drivers which are not there, not in. There are two types of drivers. The one which comes by default with the operating system. The example could be, let's say I purchase a new laptop, just the hardware, I install my OS. When I connect pen drive, it gets detected. It is because the Windows releases those USB drivers as part of the operating system itself. Then I may connect some here, some other device, let's say SSD device. If the driver is not available, then it will get we need to download those drivers and install those drivers. In summary, driver is nothing but driver is coded using embedded C language, but converted to compiled to get assembly language instructions. Assembly language instructions means what? Add, sub, move, different things, right? These assembly instructions are converted to opcode, finally into hexadecimal form. I think we are going off the topic, but okay. Hexadecimal image loaded into memory. And processor executes those instructions. This is what happens in the major topic. We open the settings, change 30 to 60. This information goes to the operating system. Operating system conveys this to power management driver. This driver consists of instructions. See, this driver is nothing but instructions for processor writing to a register in the design, which will change the number 30 to 60. Inside my design, there is a registers. Understand? Inside my hardware, there is a register. Display turn off time. There is a register called as display turn off time register. That will be changed from 30 to 60 seconds. That is how that change is taking effect. Have you understood the different aspects of electronic system? What are their hardware, firmware, operating system, and the applications? And we have understood the significance of each of these. Now, as a VLS engineer, what is important for you? Why? What? As a VLS engineer, you need to understand how the hardware works. First thing, in-depth understanding of hardware development steps. You should also have understanding of how firmware interfaces with the driver. See, someone who is manufacturing a bus, if I'm manufacturing a bus, I should know how the driver will use the bus, right? Only then I can develop a good hardware. Means what? Let's say I keep a brake in the front of the bus, accelerator in the back of the bus. For example, imagine a bus where brake is in the front of the bus, I give accelerator in the back of the bus. Can that be used? It is still a bus, right? I can still call it as a bus only. So what I have done, I have developed a hardware which is not convenient for driver to use. I have developed a bus which is not convenient for a user to use. Okay. So like even same thing with car, one side on driver side you keep accelerator, on the other passenger side you keep brake. It won't work. So there are many things. The manufacturer, the person who develops that hardware should know how the embedded system engineer will use it. So as a VLSI engineer, when I am developing the hardware, I should think from the embedded system perspective. How he is going to use my hardware? How can I make it easy for him? So that is why a good understanding of firmware behavior also is required. I should know how firmware is going to work with me. So we don't need to worry about, as a VLS engineer, you don't worry about operating system and applications. Now you see the person who is manufacturing bus, he is not going to worry about how passenger will talk to conductor and all that. Your only worry is your next layer. Let's say if I'm manufacturing bus, how the driver will use my bus. That's my concern, right? Something. So in the same context, as a VLS engineer, you need a deep, in-depth understanding of hardware process. You need a good idea of how embedded system interface with hardware. You don't need to know about operating system. You don't need to know about applications. I mean, if I'm making a mobile phone, I don't need to worry about how WhatsApp will be installed. That is something that the operating system needs to worry. My worry will be only two things: how my mobile phone hardware should be developed, how embedded system will work with my hardware. That's all. I hope you got the idea. Okay. Next. So this is about different aspects of electronic system. Okay. Now let us talk about, so what is that we have done so far? I mean, someone who is really new to this electronics concepts, electronic system concept, by now should have got a basic idea about what is VLSI, what is embedded system, what is operating system, what is application. Now let's go
Sir,
deep into VLSI design flow. Yeah, please ask.
sir, can you please explain like what would be the difference between a protocol and a driver in that case?
What is the difference between a protocol and driver? Let's take USB protocol. So let's start from the very beginning. Connect pen drive into laptop. Laptop detects that pen drive is this is my USB controller. USB controller, which is part of SoC. Okay. My laptop will have USB controller, detects, gets, generates an interrupt. Now, what is interrupt and all that? Let's not go deep into it. We are talking little advanced things which is not meant for demo session, but since someone asked a question, I'm trying to answer. Okay, those who don't understand some of those things, please ignore. Okay. So what processor knows that? Who generated the interrupt for processor? USB. So processor figures out that some device is connected. Then the processor will get to know, will download corresponding driver into its DDR memory, system memory. Drivers can be present in actually my SSD. That driver will be moved from SSD to my DDR memory. Okay. These drivers, also called as USB drivers, now starts doing transactions to the pen drive. The transactions are done as per a protocol. What is meant by protocol? First, start of frame packet should be sent. Very first thing that you should send is start of frame. Next, token packet should be sent. Next, either send or receive data packet. Then finally send handshake packet. This flow of information is called as protocol. No, we'll discuss it. What I'm telling is, let's not go deep into USB. Okay, we are just talking at a superficial level. Question is what? Difference between protocol and driver. Protocol is these guidelines. The guidelines on how communication happens. What will be the format of start of frame packet? What will be the format of token packet? Data packet, handshake packet. That whole information is what protocol talks about. The implementation of that protocol. Implementation of protocol means what? Now, what packet should be generated? Now, should I generate token packet? Should I generate data packet? Should I generate handshake packet? is what driver will decide. This driver will do that work. Then what is the role of hardware? If driver only does everything, what is the role of hardware? Tell me. It carries the information. It carries whatever frame you are generating, it carries it to the pen drive. In pen drive, it will understand, it will decode what is coming in. Is it SOF, is it token packet? That is all hardware does. Driver is responsible for generating the packets: SOF packet, token packet, data packet, handshake packet, special packets. The protocol is the rules how that should be done. So this is the difference. Is that clear to you?
Thank you, sir. Thank you so much.
Different kind of packets.
Driver, yes, it is responsible for generating different types of packets. Anything, it could be turning off a hardware, turning on a hardware, anything related to that, driver is responsible. It's so driver is not just about generating packets. It is anything you want to interface with the hardware, it's the driver's work. For example, in the bus example, bus stops for some reason, breaks down. Okay, what he goes, opens the engine box, that and he checks. That is also work, right? It's not about accelerator, brake, and clutch. So anything related to how to interface with the driver is all the role of a driver. So role of hardware is what? Carry this information, carry the packets from one point to other, means laptop to pen drive, and decode these packets, framing of packets, all that is done by the hardware. Now let us go little deep into VLSI design flow. So we will understand now different styles of VLSI design flow. VLSI, as you know, stands for very large scale integration. So tell me, what are we integrating? We are integrating transistors. Since we are integrating billions of transistors, it's called as very large scale integration. VLSI, there are two major styles are there. In VLSI, there are two major styles. What are those? ASIC, FPGA. ASIC stands for application specific integrated circuits. What does FPGA stands for? Field programmable gate array. In ASIC, hardware, it's application specific means what? You develop a hardware for specific application. Let's take an example of Qualcomm company. Qualcomm is working on mobile phone chip development. They are working, they have a team of 50 people who are working on mobile phone chip development. That can only be used as mobile phone. You cannot use it as a laptop. Okay, you cannot use it as a some tablet. I mean, it is only meant to be used as a mobile phone only. FPGA, as I said, stands for field programmable gate array. Same FPGA board can be programmed to behave like different applications. Now, same FPGA board can be used as a mobile phone. Same board can be programmed to behave like a laptop chip also. Though it needs those resources. Only if the FPGA board is good enough, we can use that. But in general, a same FPGA board can be used as mobile, can be used as laptop chip also. Which one is better? I mean, going by this, ASIC is better or FPGA is better? I mean, initially it looks like FPGA is better because same thing can be used as a mobile, same can be used as a laptop. Okay. But as we go forward, we will understand that ASIC is what is better actually. Reason is the cost of manufacturing is very less. except for cost. Everything else is good in cost and the portability. Okay, everything else is good in FPGA. It is quick, you can complete the FPGA quickly, and also the what is the time taken, and the initial investment will be less in FPGA. Is everyone facing issue with my audio?
No, sir.
Okay. As I said, which one looks better? Though it looks like FPGA approach is better, however, industry prefers ASIC design flow due to low cost of manufacturing. The biggest advantage of ASIC is the cost, because the what drives the electronic product sales. Let's say I want to buy a mobile phone. One of the major decision making factor for me is the cost. Okay, if some phone is available for 30,000, some other phone is available for 10,000 with small feature difference, which one will I buy? One which is available for lower cost only, right? That's the same reason. I mean, as you reduce the cost of the chip, see, one of the major part of the mobile phone cost is the chip cost actually. If I'm buying it for, let's say, 15,000, actually the chip itself could be 3 4,000 in that. So as I reduce that cost, my overall cost also comes down.
But
Yeah.
when you say this ASIC, right? Uh, right, but when you say laptop, it will comes as a general purpose.
No, no, laptop is not general purpose.
No.
The applications that you run is a general purpose.
Yes.
But the hardware is laptop only, right?
Hardware is
Can I use that hardware as a mobile phone? Can I make phone calls from laptop?
No. I mean, you are trying to say when we try to define one hardware that is specifically meant for only
That purpose.
processor is for only for processing purpose. That is meant for like that is a ASIC only.
No, no, no. Processor is meant for processing it. I'm talking about the overall system. The overall system I develop will only work like a mobile phone.
Okay.
Whereas in FPGA, that system, the board, can be used as a mobile phone. The same board, I can reprogram, reconfigure the FPGA, and I get
Got it.
some other hardware behavior. If ASIC is cheaper option, then why we don't do everything in ASIC only? Simple, right? If ASIC is cheaper option and it is good, then why we don't do everything in ASIC? Why at all? Why we need FPGA at all? So the point is what FPGA has its own benefits. ASIC has some benefits. FPGA has a different set of benefits. So based on your preference, what is your interest? You go for either ASIC or FPGA. So now let us understand the difference between. Okay. The problem with ASIC is initial investment is very high. So let's try to understand the difference between ASIC and FPGA. You see, let's take a look at this diagram. The x-axis is what? Tell me. What is the x-axis representing? Volume. How many units you want to manufacture? How many units you want to manufacture? Let's say I'm developing a mobile phone. How many mobile phones I plan to sell? Is what is x-axis. What is y-axis here? Cost, total cost. You see, in FPGA, what is this point? 0 units, right? Okay, I haven't manufactured any unit. I have to still hire some people, right? I need to hire, even before I come out with a product, I need to have a team of 50 people to work on the product, right? FPGA or ASIC. That cost is this one. I need some minimum investment. That so FPGA cost is this much. You may say in ASIC also same thing, right? You need to employ same number of people. This gap, you see, is mostly the tool purchase cost. I need to purchase lot of tools more than what I do in FPGA. So because of that, in ASIC, the cost will be higher initially. Initial cost will be higher. FPGA will be lower. But as you see, as you manufacture, the FPGA slope is steep. This ASIC is flat, little less. So there is a point where they both cross each other. This point. Assume this is 1000. This number is 1000 units. If we want to manufacture anything less than 1000, which one will be cheaper? FPGA will be cheaper, because if you draw this line, this is lower. So which one is cheaper? FPGA is cheaper. You understand this diagram, everyone? This is showing for FPGA and ASIC what is the cost of manufacturing as a graph. At this point, which one is cheaper? ASIC is cheaper. So there is one such break-even point where ASIC becomes cheaper than FPGA. So it depends upon these factors and this slope. There are multiple factors that decide what is this value. This red number, whatever is this point you see, let's call it as n. This number n is decided based on what is this cost, what is this one, what is this slope, what is this slope. That overallly it will decide what is the break-even point where ASIC becomes cheaper. So in summary, cost of ASIC design flow is multi-million dollars. I mean, the initial investment is much higher because we need to start everything from scratch. Once the flow is working, per chip cost will be less. Once you set up the flow, manufacturing of individual chip will be cheaper. That is why it is like this, not very steep. Whereas when you talk about FPGA, here it requires multiple million dollars. Here only require lakhs of dollars or less. Hardware is already available. Because your hardware is already available, your initial investment will be less. It's mostly the people who you need to hire the people, right, to bring up the FPGA flow. That is the investment. But in FPGA, per chip cost is more. So these are the things. Now, which companies go for ASIC based production? Companies which manufacture products for bulk uses, like mobile phone. Is it bulk uses or limited uses? Bulk uses. Laptop, bulk uses. In college, there will be one oscilloscope. Is it bulk uses? Do we use it in every house? So it is a limited uses, right? So for that we go for FPGA. In aeroplane, there will be control systems. In the pilot cockpit, right, there will be control system which is electronics. Is it used in every house? No, right? So is it bulk uses or limited uses? So they will use FPGA there. That for that matter, any electronic product can be done either using ASIC and FPGA also. Any electronic product can be done in ASIC flow, FPGA flow. What is finally drives is the cost. Which one is cost wise, which one is beneficial? Depends. I mean, if it is, let's say I only manufacture 100 units, I go for FPGA. If I want to manufacture lakhs of units, I go for ASIC. So around 85% of the companies go for ASIC because lot of electronics that we use today are bulk uses electronics, like the washing machine. Is it bulk uses or limited uses? Bulk. Woven. Lot of things are bulk uses. Only the ones which go into aeroplanes or military or education purpose, they are limited uses. Okay. Companies which manufacture for limited applications are FPGA. There are around 15% of the companies. Okay. Looking at here, tell me which domain is good for you for training purpose. Which domain should you choose? See, that is not always true. Reason is In Bangalore, if you take in a year, mostly around 2,500 to 3,000 people join ASIC training. In Bangalore alone, around 2,000 to 3,000 people will be joining. There are so many institutes, right? So in FPGA, 100 people also don't join. Now tell me which one is better. So you have to go like go by.
FPGA.
Okay, you got it right. How many institutes are there for FPGA? How many join in FPGA? Okay, there will be a scenario where you become expert with FPGA. And very next month you will get a job. Very next month, so much requirements will be there, and people won't be available in the market.
Sir,
People
but
won't be
product
available.
companies don't usually hire for FPGs, right?
FPGA engineer is required. I mean, it's not like, see, what I said is I can set up my own company where I choose FPGA as my flow. Then I need FPGA engineer, right? Why will I choose FPGA flow? Because my application, what I want to develop is a limited application. Okay, there are many companies. See, you only hear about Intel, Qualcomm. Are those the only two companies who develop hardware? Then there are other companies who work for military applications, aerospace applications, education related, medical related, medical applications. There it's probably good to for them to good to go with FPGA flow. Okay. So I'm telling you have to look into all those factors. Okay. When many people take same training, it creates competition, lot of competition. You have to choose the domains in a smart manner.
So one question, when you say FPGA flow, just then finally we have to create an FPGA boards, right?
No, no, no. FPGA board is already available to you.
Available, yes.
So what does FPGA engineer does is understand. See, front end domain is similar, same as ASIC. RTL coding, integration, verification. Till that point, it's same. Then synthesize and put the netlist, that is gate level netlist, onto the FPGA board. Do timing closure. I mean the place and route timing closure. This is much simpler than ASIC flow. The entire thing should be familiar. During timing closure, resolve the violations, resolve any. Okay, you should always choose a training domain where there is a less competition. Simple. Getting a job is all about choosing the domain smartly, not choosing a domain which everyone is joining. Choosing a domain where there are opportunities but less competition is there. I mean, not that. See, I will again tell you, FPGA has less jobs compared to ASIC. Simple logic, because there are a lot more companies working into ASIC, less companies into FPGA. But then number of people available in the market is only tens. In tens you can count. 80s, less than hundreds will be available. If I look for FPGA domain role, there will be less people. You do stand a good chance of getting a job in Europe also, US kind of, because there are companies who are working in Europe in FPGA. They are not able to find the people for FPGA. You may ask, are you FPGA trainer? No, I'm not FPGA trainer. One second. I'm just trying to tell you how to choose the right domain so that you have better chance of getting a job.
Maybe it has some its own the drawbacks.
No drawbacks. What drawbacks? No, no. Drawback in sense, of course, see, for anywhere to get a job, you have to become expert with the subject. You have to become expert with the subject. That flow, FPGA flow, what is FPGA board, understanding the different components of FPGA, able to work at little complex algorithms, I mean, floating point related. There are few things which are different, little different from ASIC. Once you learn that, there are very good opportunities. Okay. Okay. Yeah, there are companies who approach us also. I mean, now someone is asking a question. Can we able to bring FPGA based companies to our institute for placements? Yes, they do come. Why do they come is if a company wants to hire, tell me what company will do. Let's say I'm a company, I don't have a training institute. What will I do? I want to hire a FPGA engineer. What will I do? I'll say FPGA training institute, right? I'll see what all things comes. They will see Sandeepani. Okay, they will go there. They'll see VLSI Guru. They will go there. After that, there are not many. Means once Urban Pro starts means what? Then it's a very generic things. Once Urban Pro starts means there is nothing really there actually. My point is there are very limited companies which offer FPGA training. So what company will do? Will they have anything against VLSI Guru? No, they are VLSI, so I won't go for them for FPGA. Nothing like that, right? So my point is, if they need FPGA engineer, they do come to us. Many times it so happens that we don't have the people to give them. People mostly go by what many other people do. Even today, many people join physical design training. Okay, because someone told them. The problem is physical design domain is very crowded. Means lot of competition is there. Even if you tell 10 times, choose carefully, still people take. Same instead of same physical design, if a person would have done FPGA, a very good chance of him getting a job. Okay. Only thing is FPGA requires some programming, of course. PD don't need any programming. FPGA requires some programming that you have to learn. There is no alternative. Okay. Okay. And I don't have any personal motivation for FPGA. If at all I have to push, I would have pushed you for Verilog system, Verilog UVM. That is my domain which I teach. Okay. I'm trying to tell you how to choose a domain so that you have a better chance of getting a job.
And one more thing, if you are learning these things, very large system and given, is there chances of once you have experience, is there chances of moving to FPGA? So
You can do anything. See, FPGA is not like completely different from ASIC. They are lot related.
related.
Only thing is to for you to get into FPGA, you need to learn that backend flow. What is meant by how synthesis is done? How do you put that netlist onto the FPGA board? How do you do place and route? How do you do timing closure? Those aspects you need to learn. Okay. Some distinct advantages of FPGA. If if the chip has a bug, I mean, even in big companies like Qualcomm, Intel, they do FPGA prototyping. We do something called as FPGA prototyping. Before you actually go for ASIC production means what? Manufacturing. They do something called as prototyping. Prototyping means you put it onto the FPGA board and first prove that FPGA is working fine. Then you manufacture in ASIC. So if the chip has a bug which is detected after manufacturing, we don't incur big cost in case of FPGA. It can be fixed in the next FPGA board. We don't need to start from scratch. In ASIC, if there is a bug, we need to do entire flow again. FPGA is quick, means if ASIC flow takes around 6 months, FPGA can be finished in 4 months. Since we don't start from scratch, amount of time taken is relatively less compared to ASIC. In fact, FPGA is also used at one stage of ASIC flow, that is called as FPGA prototyping. FPGA prototyping is used to check the ASIC behavior before it is actually manufactured. You prove the concept on FPGA. First, whatever, let's say I'm developing one ticketing hardware, I mean, which I want to sell to buses. Before I go for ASIC production, before manufacturing using ASIC, I will buy FPGA board. I'll put my code into the FPGA board and I will first check whether that is working like a proper ticketing hardware. Once I know that okay, FPGA is working fine, that concept is called as prototyping. Then I take it to ASIC. With all these advantages of FPGA, FPGA has so many advantages. ASIC has one major advantage. What is that? Cost. Cheaper. That is the reason why 80 to 90% of the companies go for ASIC. Because at the end of the day, what talks is the cost. Same thing at lower cost. So how I think let's not go deep into cost difference. Just understand that less production means bulk production means ASIC is better. Smaller production means FPGA is better. Okay, you got the concepts right? Okay.
Sir,
Now again, one second. Please be open while you're choosing the domain. Please be open when you choose the domain. Do not choose a domain which everyone chooses. Do not just choose a domain because someone told you. Always be open to choosing FPGA kind of domains also. FPGA is not like a second grade work. It's a top class work, like the way we do ASIC. Just that you don't hear ASIC FPGA because lot of work happens in ASIC. Only 10 to 15% happens in FPGA, but there are opportunities. The biggest advantage of FPGA is it has got less competition in the market. Even if I look for FPGA engineers, I don't find many. When they don't find many, they hire what they get. Let's say I need 5 people. There are only 10 people in the market, so competition is less. In ASIC it will be different. If I need 5 people, there will be 100 people available or 50 people available, so competition automatically goes up in ASIC jobs. Yeah, please ask your question.
sir, this FPGA prototyping, is it same as emulation?
Emulation is higher, I mean more done on a more complex board called as emulation boards will be there, but both does the similar thing actually.
And one more thing, sir. When we say this real hardware and FPGA, is there any speed difference? Like,
Speed difference will be there. FPGA doesn't work at higher frequencies. ASIC can be customized to work at higher frequencies.
again, when it comes to emulation and FPGA, again, this similar.
Emulation can work at higher frequencies. Emulation is done using something called as emulation boards, Palladium, Jebu. There will be some boards, customized boards. They can give you the real hardware behavior.
Real hardware
Yeah,
behavior, but
behavior.
not real.
No, it's not a real. I mean, it's a hardware only. On that you burn it, but that is just to prove your concept that you're working on a mobile. Does it really function? So on the emulation board, you can bring up that whole process.
I mean, instead of if you have an asset, so first you can test it in the FPGA. If you want a more,
Yeah,
you can
do it on emulation. Then you can take it to ASIC production. It's clear, right? So ASIC versus FPGA. The VLSI front-end domain is very similar to both ASIC and FPGA. Sorry, this should have been like this. VLSI front-end domain flow is similar for both ASIC and FPGA. In both the cases, user needs to understand the design specification and implement the design using Verilog or VHDL languages. Where do ASIC and FPGA differ? Majorly, they differ in the backend flow. The flow starting from physical design to custom layout. In FPGA board is readily available. In ASIC, we do everything from scratch. The way we do the chip floor planning, the way we do floor planning, placement, uh, power planning, CTS routing, these steps will differ. These are the things where FPGA and ASIC majorly differ. Now, you may ask, what is floor plan, what is power plan, what is placement? This is not relevant for today's session. Okay. Any questions so far? Now, let us talk about ASIC design flow. Okay, if at all someone is interested in FPGA, there will be a dedicated demo session for FPGA also. Okay. My course, my expertise is into ASIC. Okay, so I'll be teaching ASIC flow now. Okay. Let's. What is the time
Excuse
now?
me, sir.
11. Okay, let's take a 10 minutes break. Once we meet after the break, we'll continue with the session. Yeah. Any questions?
Hello.
Yeah.
I would like to ask that you were talking about ASIC and FPGA. So they both come under design verification. Means for to be a design verification engineer, to be an expertise in ASIC and FPGA is mandatory, or they are different.
No, for a design verification engineer, both ASIC and FPGA are same. Okay, your
Okay.
question should have been reverse. I want to become a FPGA engineer. What skill set do I need? So the answer would be, you need the same expertise in the front end domain as a VLSI front end engineer, ASIC front end engineer. Your back end domain skill set will be different compared to ASIC engineer, because the way back end flow is done is different in both ASIC and FPGA. Is that clear?
Yes, sir. So you were talking about when you look for any opportunity, to be very
Your voice is
smart.
breaking. Your voice is breaking. You can ask your question in the chat window. There is a lot of background noise.
Yes, sir. Okay.
Okay. See, even when I said design verification course, everything is. If someone asked, I don't see design verification. So even that course is also same.
So is that both same for ASIC and FPGA also?
This one, no?
It's a design and verification.
No, it will be different, because we in FPGA you don't need to go deep into UVM things.
Okay.
Our idea would be to understand the design, little bit of verification concepts, and spend some time on the implementation part, the backend part. So anyway, we'll go for a break now. We'll take a 10 minutes.
When you say this IP verification also comes.
Yeah,
So
we'll discuss that after the break. Okay. So let's take a break for 10 minutes. Now, what is the time? Let's see.
This conference will now be recorded.
So now let us talk about ASIC design flow. Before the break, we were discussing about what is an electronic system, the different layers in electronic system, and we were discussing about difference between ASIC and FPGA flow. Now let us talk about ASIC design flow. I told you that ASIC related things is what we'll discuss to some extent. If you are looking for FPGA specific things, there is another demo session that you can attend as well. Okay. Having said that, once you choose ASIC as a career, you can move to FPGA. Once you choose FPGA as a career, you can move to ASIC. Very much possible. It's just that some small skill set is required additionally in both the domains that you need to learn. Okay. So now let's talk about ASIC design flow. We'll take a simple analogy to understand the ASIC design flow. Okay. We'll take an example of a house construction flow. Like ASIC flow is about manufacturing of the chips. The house construction is about construction of the house, right? Both are similar actually. There are a lot of things similar to them. Okay. So where does the house construction start with? Requirements. What do you want in the house? Okay, how many floors, how many rooms, everything, right? What kind of house and all that. Then whom do you go once you have the things? You go to architect, house architect. What will you give him? You give him your requirements. This becomes input to him. What is output from him? Architecture. Will he construct the house and give you? All right, he will give you the architecture diagram, various plans he will give you. Then you go to contractor. So when you go to a contractor, what is the input you give it? So the output of the previous stage becomes input to him. Understand, at every stage, the output of previous stage becomes input to the next stage. So what is the output from him? The building structure. Then you go to plumber. So there are various people involved. VLSI flow is also like that only. Now, how can we correlate in house flow? Can I do painting before this thing? Can I do architecture after some of these things? Not possible, right? You have to follow the same flow. VLSI also has similar flow. That flow must be followed. You cannot do physical design before RTL coding. You cannot do layout before RTL verification. There are some things which you have to compulsorily follow. You see, does house construction is done by only one person? Entire flow? No, right? There are people required at every stage. Let's say plumbing, electrician, carpentry, everything. There is a specific person required at each stage. Same way, the whole ASIC flow cannot be done by one person. It requires many people at different stages. So now with this understanding, let us talk a little about what is involved in ASIC design flow. ASIC design flow consists of 15 steps divided into two major categories. Actually, even in house construction, you can think of house construction as two major parts. One, till you come up with the structure. Second is everything after that. Means putting the tiles, carpentry work, plumbing, everything is the second part of it. Right? Same way in ASIC also, we can majorly put all the works into two categories. One is front end domain, other one is back end domain. Now, front end domain starts with requirements. What do you want from the electronic product? I mean, whatever you want to manufacture, what is your requirements? What kind of processor? What kind of display? Okay. What kind of camera? Everything, right? What kind of touch screen? All that will be there. Then whom do you go to? Architect. Architect will give you the architecture. Then you have a team called as design team. They will use Verilog language to do the RTL coding. RTL stands for register transfer level. Once RTL design is done, the next thing that we do is integration. Design means developing small blocks is called as design. Integration means putting together those blocks to get a bigger block is the integration. Okay. Let's say mobile phone is there. Mobile phone consists of processor subsystem, camera subsystem, audio subsystem, peripherals, various things are there. Okay. A battery is external component, but those things we put together: processor subsystem, display subsystem, graphics processing unit, the camera subsystem, like that. Connect everything. I mean, not randomly. There is a specific rules how they should be connected. This whole thing is the SOC. That work is called as RTL integration. Putting together everything to get a system is the RTL integration. Now we need to check whether whatever we have developed, is it working properly or not. Otherwise, what will happen? My mobile phone won't work properly if I didn't connect them properly. Okay, let's say while integration of my laptop, they didn't connect one wire properly. Will it work? Same thing will happen with my ASIC also. If they miss some connection, it won't work. So we need to do something called as RTL functional verification. See, design, integration, functional verification. Then As part of front end only, we do something called as DFT at the Verilog RTL level. They do some design for testability at the RTL level. We'll talk more of that later. So this is all what constitutes the front end domain. Now, why this domain you should be looking, I mean, understanding these domains is these aspects majorly. The three, what are those three? RTL design, RTL integration, and RTL function verification. They require coding expertise. They require coding expertise. I mean, coding means what? You should be good with Verilog programming, Verilog language. You should be good with system Verilog language. All those things. Coming to the backend domain, there is no coding expertise required. You don't need any coding expertise at all. Like synthesis, it starts with synthesis. Synthesis is a part where we convert this RTL code, whatever you have developed in Verilog language, into gate level format. Gate level means what? AND gate, OR gate, XOR gate. In that format, it will come. That conversion is process is called as synthesis. Once it is converted, we do DFT at the gate level also. Then we do physical design. Then we do static timing analysis. Then we do custom layout. Then we do physical verification. I'm not going deep into it. Reason is today our focus is only on the front end. Generally, these topics are discussed in more detail in the backend domain because if I talk about everything, my demo will go for 5 hours. So I'm just trying to limit what is relevant for today's session. Okay, this is important. GDS2, which stands for Graphic Design System Extraction. What is this file is basically it will talk about how my chip finally will look at semiconductor level. I mean, if this is my silicon wafer, where the oxidation should be done, where the metal deposit should be done, where the doping should be done, where the polysilicon should be deposited. That level of description it will tell how much doping should be done, at what depth the doping should be done. All that they will do. So you may say, what is there? It is very simple, right? The complexity is because this is for just one transistor. Like that, you have hundreds of 100 crores of transistors are there, all fitting into 1 square centimeter. How many transistors are going into 1 square centimeters? 1 billion transistors are going into 1 square centimeter. Because of that, the fabrication is very complex process. So when you give them this GDS file, it's like it'll tell in a graphics manner. This is where oxidation should be done. This is where doping should be done. This is where metal should be deposited. Then accordingly they will set up masks, various layers. Okay. Then they do the fabrication process. Finally, when you give GDS2, using GDS2, they do what? Fabrication. Once the fabrication is done, you will get the individual chips. You need to check whether they are working fine or not. That process is called as post silicon validation. What is post silicon validation? Once the chip is fabricated, whether it is working fine or not, that process is called as post silicon validation. Then once you know that chip is good, then it goes for packaging. Means finally it gets packaged into a final electronic product.
But usually, after packaging only we'll get the final chip, right? I mean, post silicon is a different and packaging is a different.
Yes. So if you package this and then do the checking, if it is not working fine, the whole packaging is gone, right? See, the chip cost is $30 only. After packaging cost is, let's say, another $30. Your additional $30 is wasted. Packaging means this whole thing. This is not the chip. What you use? This is not the chip. Chip is a one part of this phone. So chip is the heart, right? I mean, heart or brain, you can say. Whether that chip is functioning fine. If it is functioning fine, then you make the product. Otherwise, throw off the chip. Got it, right? What is this? Now, since today's training is on front-end domain flow, we'll only focus into front-end domain flow only for today. Okay. Um, Ideally, I do talk a little bit about other domains. Wait, uh, I think it should be fine. Now let's talk about front-end domain flow. The VLSI front-end domain flow is similar to software flow. How we do software flow, right? It's similar actually. In a software flow, what is the skill set they require? They need C language, C++, and Java. They should be good at reading software design specification. They should understand what is the software is about, what is the specification. Based on that, they develop algorithm, implement that algorithm using C, C++, or Java. What does VLSI front-end domain engineer does? You need to learn Verilog, SVUVM, read, like here you are reading software specification, here we need to read hardware specification, implement these requirements using various protocols. Like here we use algorithms. In VLSI, we need to learn protocols like USB protocol, AXI protocol, APB protocol kind of things. USB, PCI Express, DDR, AMBA, SPI, etc. Okay, what is where do they differ? Fine, they are similar in the front end domain. Where do they differ? The major difference comes because software doesn't have backend flow. In a software domain, there is nothing called as backend engineer. Backend domain is not there. Okay. What is mean by backend flow? The process of converting Verilog code into a chip. That whole process is called as backend flow. Do you think is this required for a back software? Sorry, no, right? In software, you directly install the software and use it. When you buy a software, do they sell a chip to you? No, right? What do they sell? They sell a piece of code that you can install and use it. So in software, you don't need to do the fabrication, you don't need to convert to hardware. So that flow won't be there. VLSI chips don't have any concept of patch. See, thing is patch means what? I'll tell you. You developed a software. There is a bug in a banking application they have developed. There is a bug in that. It is possible, right? That bug can be fixed and you can reuse the same software with the bug fixed. In hardware, it's not possible. Means what? Once you manufacture the chip, this chip is not functioning fine, functioning properly. I cannot do modifications. I have to do the entire process again. Hence, the verification plays a very important role in VLSI. Mean in software, even if testing goes wrong, something you released a product with some small bugs, they can still be corrected. In hardware, once the bug is there, you cannot really fix it. You have to do the entire thing again from scratch. Hence, verification plays a very important role in VLSI. That is why you see a lot of opportunities, job opportunities, and a lot of people also joining the courses for verification courses. We have already discussed what is involved in pre-synthesis flow, requirements, architecture, design, integration, and functional verification. We also talked about backend domain flow, like synthesis, GLS, BFD, physical design, STA, custom layout, so many things are there. Let's quickly talk about what is DFD is about. Let me write here. DFD stands for design for Testability. Design for testability. Wait 1 second, I will have it. Fine, I will explain here. Basically, DFT stands for design for testability. What happens is we are manufacturing the chips at very low technology nodes, 5 nanometer, 3 nanometer technology node. What is this 5 nanometer, 3 nanometer? This is the channel length. This is the channel length of the transistor. What is channel length? The distance between source and drain is the technology. When you are manufacturing at that level, can you imagine what is 3 nanometer? Very, very small thing, right? Very small thing is the 3 nanometer and 5 nanometer. When fabrication is done at this low technology nodes, even for that matter, 100 nanometer also very small, right? There are manufacturing defects. Manufacturing defects can happen, which user can't see. Just by looking at a chip, I cannot tell does it have a fault or is it good because it's at very low level. It's not visible to your eyes, or even if it is visible, it's inside the chip, inside the silicon. If something happens, what how can you fix it? You cannot see, right? Because it's already closed now. Let's say inside my laptop there is a bug is there. How can I check it? Because it's closed now. Okay. So we need techniques which help detect these faulty chips. You should be able to identify which chip is good, which chip is faulty. So for that we use some techniques called as, those faults are basically stuck at fault. Means something is always stuck at zero value. Something is always stuck at one value. It's a fault actually. At speed fault, different types of faults are there. So we want to detect whether these kind of faults are there in this in each chip. If I manufacture 100 chips, out of that, I want to know how many chips are good, how many chips are bad. So the process of identifying that good chips and faulty chips is what is involved in DFT. Okay. What DFT engineer does is DFT engineer has uses scan, ATPT, that is automatic test pattern generation, built-in self-test, some compression, JTAG, boundary scan techniques to develop patterns. He develops test patterns, which these test patterns, when you apply as an input to the chip, these test patterns, when you apply as input to the chip, the output will tell whether this chip is working fine or is it faulty. Let me again repeat. What does a DFT engineer does? DFT engineer develops some test patterns, also called as test vectors. These vectors are applied as input to the chip. The output, by looking at output, we can tell whether it's good or is it faulty. If it is good, it goes for packaging. If it is false, if it is faulty, you drop it off. This work of applying test patterns is done by post-silicon validation. The role of a post-silicon validation engineer is he will take each chip, he will apply those vectors, the one which are provided by the DFT engineer, and he checks the output. If the output is coming fine, the chip is good, otherwise it's faulty. Clear to you? So I hope you got a basic idea about DFT. The good thing about DFT is you don't need any programming expertise. It is mostly the software oriented, tool oriented. Where you need to learn the tools to do scanning, scan, ATPG, BIST, all those things. With this understanding of the entire flow, let's now understand what all job roles are there in VLSI domain. Let's now understand what job roles are there in VLSI domain. In VLSI domain, majorly as you know, there are two domains, front-end domain, back-end domain. Based on what a person does, you just add engineer in the end, that is the role. Okay. Design requirements are done by marketing team, architect, design architect, RTL coding, RTL design engineer, RTL integration engineer, RTL verification engineer, DFT engineer. Like that, for every role, there are specific engineers. So what am I trying to show here is that there are these many different job roles in VLS. In software domain, it is simpler because there are only majorly three types of roles are there, three or four. One is architect, software architect will be there, right? Then software developer. Third one is what? Tester. These are the only three things. You cannot anyway become architect. When you pass out of college, you cannot become a architect because it requires a lot of experience and expertise. So you only have to choose between two roles, whether you want to get into developer role or tester role. Very simple, right? There is no confusion. If you decided to get into software job, simpler. In VLSI, confusion is there because so many roles are there. You can become design engineer, integration engineer, functional verification engineer, DFT engineer, synthesis, everything. And everyone does different work. Let's say in house construction, what plumber does carpenter do the same work? All right, each has its own expertise. I cannot call a plumber to do carpentry work. Same thing here. DFT engineer cannot do functional verification work. For example, I worked as a functional verification engineer for 14 years, let's say. I never did anything here. And if they even ask me to do physical design, I cannot even touch it because I don't know the flow, I don't know the tool, I don't know the concepts which are involved in that. Okay. That is where you have to choose between which domain you want to get into. As I said, in software, it was easy because developer or tester. Here, there are a lot more roles. So how do you choose it is, majorly, first you start with choosing whether I want front-end domain or back-end. How do you decide between that? If you are interested in programming kind of job, coding related job, you are okay and you are comfortable with it, you can go for front-end domain. If you don't like programming at all, then you can go for back-end domain. In the institute, we have a flexibility where you choose any domain. Let's say you choose front-end domain, you can switch to back-end domain up to 2 months, or vice versa. You can switch from back-end domain to any front-end domain without any additional cost. Now, let's understand, with so many job roles are there, what is the team distribution? Let's say you go to some company where there is a team of 50 people working on a specific design. If the total team size is, let's say, 50 people, so front-end domain will require around 25 to 30 people, which is around 50 to 60%. Only one architect will be there. Design team will have around 4 to 6 people. Functional verification team will have 15 to 20 people. So that's around 30 to 40%. That's around 30 to 40%. So what are in which domain there mostly the front end domain job roles are there? Functional. That is why a lot of people join functional verification domain training only. Now you may say why so many people are required. Design mostly works on reusing. Mean, let's say I'm working in we have one version of iPhone. The next version of iPhone uses lot of things from the previous version. They don't redo everything. But when you go to when it comes to verification, even if they have reused, you still have to verify, because during the reusing you may have done some small mistakes that need to be verified. That is why you need more people for verification of this. Now tell me how many people backend will have? Around 20 to 25, which is around 40 to 50%. DFT will require around 2 to 5 people, physical design around 10 to 15 people, ST around 3 to 5, layout around 3 to 5. You see again, where do you have more requirements in backend? Physical design. So that is where, now you may say, why do lot of people join here is for training is these two domains, physical design and functional verification is, uh, can I hire a fresher for architect role? No. Companies even don't hire freshers mostly for design work, because anyway you have 4 people. If you keep a fresher, then again you have to teach everything. Rather they go for experienced people. Whereas when you need 50 team of 20, you can keep around 12 people experienced, 8 people freshers. Here also when you have 15 people, let's say, you can keep 10 experienced people, 5 freshers. That is where you see 8 plus 5 openings gets created. For whom? Fresher roles. That is why lot of fresher hiring happens in functional verification and physical design. Again, if you ask me, is it not possible for me to do get into design or STA or layout? It is possible. I mean, okay, here also, of course, these STA layout and DFT also fresher hiring happens, because whatever work they're okay for a fresher to do, they will assign. Again, don't think that because there are more uh, number of people required, there will be my chances will be very easy to get a job. Not like that. Competition also will be higher only. Number of people who join functional verification training, number of people who join physical design training is higher compared to DFT and layout. You got the idea, right? I mean, I was just trying to give you a team distribution, how the number of people will be in different teams. Okay. So now let us talk about the training schedule. Mode of training. Training is available in full week, 3 modes: full week, weekends only, weekdays, evening batches. I'll talk about this one also. Uh, Full week training is available in online mode, offline mode, and hybrid model. Hybrid means partly you can attend online, partly offline. In this full week training, you will get recorded video access for 2 weeks for every session. In weekends only mode, online sessions, a dedicated mentor for offline doubt clarification. What happens in weekends is it's mostly the working people who enroll for this course. They're mostly comfortable attending the session from home. Okay, but anyone wants to come to the institute and get the dedicated time from the trainer for doubt clarification, it is possible, and offline itself. You get access to all the recorded videos for entire course duration. Next, weekdays, evening batches. But that is, it requires minimum number, only then we do. If there are only 1 or 2 people, it is not possible for us to do that. Instead of that, they can go for weekends only course. Irrespective of mode of training, every student has a dedicated mentor for doubt clarification. Generally, what we do is anytime any student enrolls, small course or big course, we create a dedicated individual WhatsApp group. So you post all your queries in that group. Trainer will be there in that group. He will support you. Either if it required, he will reply in that message in that group, or you can have a dedicated call or meeting with the trainer to clarify your doubts. Okay. So this is a brief about mode of training. Now let's talk about, as I said, when I say RTL design and verification training, it is same as design and verification, ASIC verification function. All of them are same. Let us talk about functional verification training. It's a 8 months course, 6 days per week. Sunday will be off. Around 4 to 5 hours per day. Sometimes the sessions can be after lunch also. Mostly we try to keep it in morning, but sometimes it's possible that it can be after the lunch also. Uh, how this 4 to 5 hours will be spread will be 1.5 to 2 hours of theory session. Around remaining 3.5 hours of lab session will be there. Every session recorded video access for 2 weeks. We have a portal called as www.inskill.in, which is our own portal, where it's our e-learning platform where you get access to the videos. All the course presentations, assignments, and notes are uploaded to e-learning platform. Once you log in, you get access to everything. Printed course material provided for all modes of training. It could be online, offline, or hybrid model. Let's say even if you are in some outside Bangalore, we send the printed material over the post for every course you enroll. Talking about functional verification training, we purposefully kept 8 months of training. Simple few reasons is that uh, when you want to get into job, see, BTech is different and training is different. How they are different, let's understand. In BTech, the main motive is to get a good percentage, get around 75-85%. Okay, it's good. Okay. Uh, Job is not the primary focus when you are in BTech. Your college also main focus is percentage, getting people passed or get the good percent scores, and then finally placements will happen. Okay. When it comes to training, our focus is not the percentage. Our focus is whether the person is ready to work in the job. Let's say you go to Intel in a fresher role, will you be able to work there independently? We don't want a scenario where some senior sits with you every minute and tells you do this, do this, do this. So that is a difference, because we have to prepare a person who will be able to work independently in the job. That requires a lot of time to ensure that you learn the things as per the industry expectation. Many times for that, 5 to 6 months is not sufficient. Actually, in 5 to 6 months only you learn the basics. You don't get time to learn the advanced aspects, the way things are done in the industry. In many cases, the people who join 5 to 6 months of courses, the companies again ends up training them internally. Let's say some company HCL will hire you. They will again take you through 3-4 months of training, because they feel that your skill set is not meeting their requirement. That is where what we have done is we have increased the duration. It gives us three advantages. One is, by the time you are passing out of the institute, we know that your preparation is good. Second, when you join a company, they don't need to really do a lot of training for you. 1 month is sufficient. Instead of 3-4 months, they can finish off their customized training in 1 month. Third is, institute reputation will be good, because when you go there, you don't perform well, they make a bad impression of the institute. Okay, I mean, 5 people working there represent the institute. If you perform well, also you give the good name. So how you do reflects the institute name, brand name. So we don't generally hurry in completing the course, because see, we don't want to bring out an unfinished product into the market. I mean, it is not good for the student also, not good for the company also, not good for the institute also. Rather, we spend more time and do little more in-depth training. I mean, not that I do only 2 days of training per week and that's why it goes for 8 months, not like that. Every day session will happen. Even we push training on holidays also, festivals also. I mean, some, I mean, except for important festivals like Christmas, Sankranti, Ugadi, major festivals, we take session every day. Okay. Still it goes for this much duration. Okay, now you may say why other institutes don't do 8 months. Mostly it is limited by the number of training rooms available, the rooms facility. Um we have around 10 training rooms and we have enough trainers to run multiple batches parallelly. So it may so happen that because it goes for 8 months, we can have around 5 to 6 batches running parallelly. There is a batch which I have started in last year May or June, which is in the final closing stage. The one which I have started in July is also running now. One which I have started in October is also running now. So 5 6 batches could be running. We have enough facilities to handle multiple parallel batches. Now in many other institutes it's possible that they may have 2 or 3 training rooms. You cannot really accommodate 5 6 batches into 3 training rooms. Either you have to reduce the number of hours per day, you have to reduce the course duration. They prefer doing one of them. Okay. uh, Anyway, they will have their own advantages, so I don't want to only point out negatives there, but we have some advantage which ensures that we focus on the quality also. We divide the whole 8 months of training into 3 phases. Okay, now you may still say 8 months means my placement scenario will be delayed. Even in 8 months you start getting placement support after 5.5 months, because last 2.5 months, 2 3 months is focused on the industry project. That you, even when you join into a company, you can do, the company will allow you to do the training. You can switch to, from full week you can switch to weekends only mode at that time. So that is where we divide the training into 3 phases. Phase 1 will go for 3 months, where we cover advanced digital design, Verilog and Verilog design projects, and we also teach GVim text editor. In phase 2 we teach system Verilog and UVM, Linux commands, and soft skill training. See, soft skill training is something that is done every week. It's not done in a 2 3 days. It's a something that happens every week. It is mostly targeted for people who are coming from non-metro background, means town and villages, rural and town background. Because many times the difference between getting a job and not getting a job is the communication skills. Many times you may have a technical knowledge, but you don't get job because you cannot communicate what you want to speak. I mean, what you want to tell, you are not able to properly communicate. And that skill set you don't learn in a day or two. It is something that happens over a few months of time. So our soft skill training, which happens once or twice every week, helps the student gain that I mean, improvise on that. And they are focused on how to explain, talk about yourself, how to talk about the work you have done. Okay, how to attend the interviews, those kind of skill set. See, placement support starts after this time only. You don't need to wait for entire training completion. Even after this, placement support starts. Phase 3, here we do multiple industry standard projects, like projects based on AXA protocol, AHP protocol, Ethernet MAC. Python scripting will teach, SOC flow basics. So these are the things which we cover in the entire 8 months duration. Okay, sometimes the training can even go for 9 months also, but the base point is that your placement support starts here. So once your placement support starts, you get a job, you don't have to worry about that whether remaining thing goes for 2 months, 3 months, or 4 months. Having said that, the delay 9 months don't happen because we cancel the sessions. Every day sessions happen. It's just because students, if they cannot catch up, the session slows down. Same topic, I'll tell you. If I get a whole batch is selected, let's say if I pick only people with 80 85%, if I make a group of 30 students, Everyone having 85% plus in BTech. The same 8 months, I can finish it in 5 months because they pick up the things very quickly. I don't have to teach the same thing for 1 hour. I can teach the same thing in 40 minutes, done. And more importantly, person at this level, they do a lot of homework actually. I don't need to tell complete this assignment and come. They even without I telling, they do that. The problem that we face is people lack motivation many times. There the course gets delayed actually. Like you might be knowing Veda IIT, right? There they pick only 60 people. Even if I get same batch, I can do the same thing in 5 months. The same course with the same effectiveness can be done. Here we don't pick the people, everyone joins. Next. Phase one, phase two helps in getting the job actually. This is what mostly other institutes are focused on actually. Phase three helps you perform in the job because the projects that you do will be like very much industry relevant actually. The way you do the work, way you do the debug, that activities will be relevant. So both are important. One of them will helps in getting job, one of them helps in doing well in the job. Almost all other institutes training stops after phase two. Okay. Uh, Other institute do a small project, okay, which is not in line with the industry requirement. I mean, I know one institute which is doing the same projects since 2008 till now. Means industry has changed a lot in last 15-20 years, you know, right? The phones, the electronic products. Can we do same project what we did in 2010 in 2024? Right, it won't be relevant. So where we keep uh, upgrading, why we do that is, I mean, I drive it. Having worked in the industry, I am good with other aspects. Like for example, we offer courses in many other things. Let's say SOC, debug techniques, ARM, UPF, RISC-V, even the protocol courses. There are many things which we offer. It's because of the expertise that I have gained or my other colleagues have gained while working in the jobs. Okay. Next. Functional verification for, I will be finishing in another 5-10 minutes. Then we'll go for question and answers. Only difference between fresher and experienced course is a experienced person don't need digital design and Verilog because they're already good. So mostly this course will be focused on system Verilog, UVM and industry projects. System Verilog, UVM and industry standard projects. Otherwise, both of them are same. What is difference is, in this course there is no digital design and there is no Verilog. Additionally, you are doing UVM advanced course, which a fresher don't need. The fresher doesn't need this topic. Only for experienced people this topic is done. In experience course there is no digital design and no Verilog. That's the only difference. Okay, FPGA, let's not get into these things for now. I mean, there is a flow, we again do it in multiple phases, this one also. uh, DFT, I'm not going to talk. I mean, there is another session where we'll talk about that. DFT related, DFT specific demo session where we'll talk. Next. Next, how to choose the right course. Okay. There are three kinds of expertise. Okay. One is functional verification. When will you go for functional verification? It requires a good level of programming expertise. You should be good with programming. Opportunities are there, job opportunities are there. Uh, FPGA system design, medium level of programming expertise. You don't need a lot of expertise, but you should be good with Verilog. Expertise of working with the tools, and there are job opportunities in FPGA also. Less number of engineers available for hiring in this domain, hence your chance of getting a job is better. Third one is VLSI backend domain, like physical design, DFT, STA, custom layout. No programming expertise. It doesn't require any programming expertise. Mostly tool and technology oriented job. So like this you choose. If you are good with programming, you go for functional verification. If you don't like programming at all, you go for backend domains. If you are okay with little bit of programming, you go for FPGA system design. As I said before, you always have a choice to switch within 2 months. So that once you join, you explore, you know more about the course, you get to see it. Then you may say, what if I will miss 2 months of the other training, right? Initial 1 month is common, that you only miss 1 month, that you join into the next batch of the other training. Because of that, you don't miss anything actually. Your 1 month gets added. Instead of 6 months, your training goes for overall 7 months. Other than that, you don't lose any topics. Course flexibility, as I said, you join any course, switch to any other course up to 2 months, no additional cost. No need to repeat the entire 2 months in the course. Like initial 1 month is common. As I said, you join into the next batch. Next, preparing for the job. Okay, this is important because there is no, it's not a 1-to-1 ratio. I mean, if there is one job in the market, there is not one person. There are a lot more applicants compared to number of opportunities. What is the difficult part of the training at VLSI? It could be applicable to any other institute also, but I will talk only about our institute. The difficult part is things move quickly. Uh, Means what? 8 months of training that you do here, you can compare it with 2 years of BTech. Whatever learning you do in 2 years of your engineering, it could be similar to that much amount. Uh, I mean, you may say, how can 8 months be equal to 2 years? Your 2 years is not really 2 years, right? You have so many semester breaks. Okay, a lot of things are there. The classes doesn't go full day. Lot of things are there. So essentially, we run 8 months full fledged. Only one day break, and every day has assignments to work on. In college, you don't have assignments every day. So that 8 months gives you expertise of almost doing a 2 years of whatever you did in BTech. Okay. For example, we do 3 weeks of fully focused digital design, which you do it over one semester time. And the amount of content we cover is more than what you do in BTech. Let's say in BTech, you may only cover about what is K-map, what is truth table, what is De Morgan theorem. Probably that stops there. We cannot stop there. The problem is, as an institute, I cannot stop there, because when you go to the job, expectation is that you should be expert in digital design. You should be knowing flip-flops, latches, applications, counters, edge detectors, clock dividers, clock frequency multipliers, everything. They want you to be expert. So we cannot do the way it's done in the BTech, to be very precise. Okay, digital design is spread over in the BTech, spread over one semester. You have so much time to prepare it, whereas in our case, 3 weeks only digital design, no other topic. There things gets little difficult for you. Okay. uh, so what should do you do? You should learn to complete things in sync with the trainer. I mean, if you don't complete in 3 weeks, what happens? You'll have backlog. I mean, some topics backlog. We While you are doing, new topic will start, so you have to keep in sync with the trainer. If you ask me, does it mean that I cannot manage in 8 hours in a day? You can very much manage. The amount of topic done in a day is not like you cannot manage at all. It's very easy. Only problem comes is students are not what do you say, consistent with the preparation. Let's say, if you decide that every day I'm going to spend 8 hours for my preparation, including the class time, you will get a job in 7 months. You just have to tell to yourself that every day 8 hours I'm going to take, whatever happens. 4 hours for class, 4 hours for my homework, assignments. Then you can easily cope it up. We are not going to run through the course. We are not going to. We just that same topics are done, taught in a better manner with relevant examples. Okay, which you have to practice it. The same applies for other course also. Let's say Verilog we finish in 8 weeks only. Lot more things are done compared to what you do in BTech. Uh, Simple thing is a good 6 hours effort per day, 6 to 7 hour efforts per day, including session time. Include the session time also is sufficient to get a job. The people, why people don't get job is two reasons. One is the people who join, many some of them don't have the proper aptitude, quantitative aptitude. Okay. Simple things like time and work, distance and time, those kind of things will be there, right? That skill set, if you lack, the person cannot really comprehend the things which what we teach. When you may say how VLSI is related to aptitude. Aptitude tells your ability to understand the things, ability to correlate the things, right? That is skill set is required here also. If a person with comes with a very poor IQ or aptitude skills, it's very difficult for us to teach these topics. So my suggestion always to everyone is, before taking up this course, need not be in our institute, anywhere you take, before that you spend 1 month full time, just do full quantitative aptitude, only quantitative aptitude, become good with the basic calculations. Okay. uh, okay, so that is very important. Then you will become capable of understanding what we teach. Performance tracking. We have a performance tracking mechanism where we rate students into three categories: good performing, average performing, poor performing students. Idea is not to discourage some students or anything. Idea is to find out how to support them. I mean, do we need to do some additional sessions? Do we need to do some support sessions related to the assignment? How can we make a good student into by teaching additional topics, those kind of things. Okay. We have some performance tracking parameters, like assignment is the most important thing. Every day there will be assignments. Assignment don't mean that you only have to do everything. For every assignment in the institute you get the guidance, like there will be a lab sessions is where you do the assignments. Lab sessions are done for every assignment completion. 10% only for attendance. Many times I may not even bother whether you come or not, as long as you do the assignments properly. 20% for evaluation test. Every at end of every month or every topic we do an evaluation test. Then 10% for presentations. A student is given a topic, they're asked to do the presentation on the topic. That way, over 8 9 months, you improve your skills, communication skills, the way you explain the things. That helps with your interview preparation also. Okay. And 10% for mock interviews. Okay. A dedicated WhatsApp group for every student. Okay. Where in that group, trainer, admin, and student are there. Whenever you have doubts, technical doubts, trainer will help. Non-technical, admin will help. What is the final goal of 8 months of training is student should be enabled to work in the job independently. Okay. If I go to a manager in Qualcomm, Intel, or anyone, he asks me, I need one fresher. His only goal is he doesn't want you to do any research and development, no innovation, nothing. His goal is simple. I give a simple activity. Can he do independently? So you go to the job. His goal is only one simple thing. Without any additional support from my side or my team, can this person work independently? Mostly the people who complete their BTech freshly out of college, they cannot do, because the job has different requirements which you don't learn in the BTech. So our training is to fill that gap, and that's where we spend a lot of time. I mean, if my only goal is only to complete the training, we do in 5 months also. For me, easy, right? In completing in 5 months, I could even say I will skip the main project and I keep a simple project. Instead of doing for 3 months, I can do a project which will go only for 2 weeks or 3 weeks, and I can finish entire training in 6 months itself. For me, the 2 months is saved, right? uh, but the thing is, it doesn't help, because the institution reputation is all about what kind of students pass out. let's say if IIT has some reputation, it's not because of the campus size or any reason. It's the kind of people who pass out and what they do. Okay. Same thing. What are the course prerequisite? Only prerequisite in the course is good with quantitative aptitude. You don't need to come with any good digital design skills. You don't need to come with any good Verilog skills. No programming skills. Nothing. Nothing is required. A good quantitative aptitude skills are required. Student, I mean, basically, it should person should have ability to understand the problem and correlate things. Should be able to do logical analysis. uh, Take a simple test. You go to internet, you take one quantitative aptitude test yourself. If you score less than 30%, don't join the course. Don't join the course right away. You prepare for 1 month, you be good with QA, then only join any training. Otherwise you will end up wasting your money. Okay. Reason is it helps me also. If I have a batch with mixed thing, right, where one person is smart and is able to pick up, one person cannot pick up anything, my pace gets disturbed actually. Not only me, any other trainer for that matter. So if you take your test, these are serious suggestions you have to take. Okay, it's not for just any random person, it's for you. Everyone who is attending the session should be doing this. Just go to internet, one quantitative aptitude test you take. If you score less than 30 or 40%, you definitely should not join the training. Even if you have joined already, you can delay it by 1 month. Spend one full month, do quantitative aptitude, different types of questions, full day, full month. After 1 month, you come and join. You will see the difference. So other than this, no prerequisite, no digital design, because everything is taught from the basics. Many times, what happens is people enroll. I mean, why to join VLSIGuru? Many times I have seen people who enroll in other institutions. I don't want to name. Then they do come to us for other courses. Other institute do teach digital Verilog SV, to some extent UVM. Then when it comes to AMBA courses, there are some protocols and industry projects, they do come. There also they spend 1 lakh, here also they spend another 20,000. Rather, why to do that? You spend 40, 50, 60 here only, do the entire thing properly. Okay. Now when it comes to placements, how it works is companies don't really have any differentiation for Institute XYZ, Institute ABCD. When you go to a company, they don't even look at your institute name, they look at your skill set, how good you are. Because my same institute, VLSIGuru, can produce a very top class student. It can even produce a student who don't know anything else. It's because training is not just about the trainer, it's about the student also, how much effort he puts and learns. So that's where two people can generate, who is one is very good, one who is not good at all. So companies cannot go by, if he is from VLSIGuru, he'll be super like that. So they will do all the interview. So what really matters for you to get a job is the skill set that you gain, not the institution brand name. Right? It applies everywhere, any college, any institution, anything. So more than institution, it's a skill set what you should look at, what skills. So in our case, what we do is we teach all the skill set that is required from the very basics. uh, what is really differentiating factor is the time we spend. I mean, at the end, your quality of your preparation is the time that as an institute we give you. Okay. So that completes what I wanted to talk about. Any questions? Now we can discuss any questions you have. Choosing right domain, we have discussed. Why VLSI job? Yeah. Yeah, why choose a VLSA job? We'll just quickly talk about. One is work satisfaction, because you work into a domain where you have done your bachelor's and master's. There are good job opportunities, career opportunities in India and abroad also. VLS has almost 50 product companies and 100 service-based companies. Okay, so you can get into those companies. There is no significant requirement for reskilling once you get the job. Means, read the third statement. There is no significant requirement of reskilling once you get into job. Means, I learned system Verilog in 2006. UVM in 2008 or 2009 actually. Okay. Today also, I use the same skill set. If you ask me what is that I learned during this 10 years, is some protocols, new things like PCI protocol, CXL protocol, DDR protocol. The common skill set I don't have to redo. Let's say in software, what happens is every 5 to 8 years, 7 years, new technologies changes. Like sometime it was mainframe, sometimes it is .NET, sometimes it is big data. Now it is data science. Data science was there, then artificial intelligence. We don't know what new things keeps coming. Many times in software they have to reskill lot of things, they have to learn new softwares and all that. In VLSI, because it's a flow, chip manufacturing flow that doesn't change. So you don't have to reskill. The effort is all in the beginning actually. See, if you at this point, software person who undergoes software training is very easy for them. Undergoing VLSI training is tough because lot more things need to be learned. But once you get into the job, other parts are relatively easy because you don't have to reskill every 2 3 years. VLSI is generally well paid job, well paid job. A 5 year experience engineer in VLSI can earn anywhere between 15 25, even higher. Many times people say I get 30 35 lakhs. I'm just telling what is average numbers. Okay. Okay. So this is about the demo session. Now, if you have any questions, I can answer those.
So almost this IP verification and RTL-based verification is
Same. Yes.
So,
largely the
which
same.
one has more job prospects, the front end
No,
or the
your
back
voice is
end?
breaking. See, the person whoever is talking, your voice is breaking. Andrea, please post your
Yes, sir.
questions in the chat window.
Okay.
Any other questions? Which tools? Okay. Any other questions? Uh, Wait. Any other questions?
Lab sessions will be getting daily and
Lab session schedule. Okay. Any other questions?
change from software domain to user.
One second. Can we change from?
Software domain to
Any other questions? Okay, fine. Let me address these questions. You are saying you need to be smart when choosing domains for your jobs, sir. Which one is demand now, front end or back end? What is the difference between these two? I told you, right? Front end, back end, both have the opportunities. Both are in demand. I mean, demand is a relative term. What is demand means? If everyone gets placed, it's a too much demand. Now, so much demand is not there. Way the placements were happening in 2021, 22. Now it's not happening. 23 was a slowdown time. Okay. Now things have improved a bit. Now means last 2 months things have improved. Before 2 months, it was very dry. I mean, less placements. Now, what is the difference? I told you, right? Difference I have already told you. Front end domain requires programming expertise. I think I have this question was asked before that. Back end domain requires tool and technology understand expertise. Should be good with the tool, should be good with technology understanding, all that. Okay. So I hope this. I mean, I will answer the questions. If you still have any questions, follow up questions, please ask me. Okay. Salary wise, which is better? The VLSI domain as a whole, it's a good paying domain. What may happen is a physical design engineer may get 5 to 10% more than DV engineer, design verification engineer. I'm just telling a possibility. The difference won't be like 20, 25%, because his work is lot more involved than this. Many times they have to work full day, full night, which DV engineer don't need to. I'm the good example. Uh, I have done that job, and I have also set up an institution parallelly. I was doing training and job for 7 years, proper 7 years. I did job, I did training also, because in my time I was able to manage my job, and I was also parallelly able to run the institution. Only when I felt that now I'm good with my training, I quit my job and I'm now into training. In PD, it's difficult. Someone who is working as a PD engineer, for him to set up an institution and run an institution would have been difficult. Reason is, it is a very involved job actually. I mean, small issue also comes, they have to do lot of things again completely. Okay. So otherwise, salary wise, every domain is better. See, the point is what, once you get 30 lakhs, for example, whether you get 30, 32, 34, is there any difference in these numbers? Four numbers, three numbers, 30, 32, 34. No difference, right? Same is. Difference is around 10%, 10 to 15%. But if you ask me, really, is there any difference even in your lifestyle? You won't see difference. But if you like the domain, then it's good. Let's say you like physical design domain kind of work after experiencing it, then it's good. Whether they give you 34 or 30, you still like it. But doing a work where you don't like the domain, that will be a problem. So if it is all about salary, every domain is a well-paying domain. And the problem is, it's a range. It's not like a fixed number. It's not like 5 years means 35 lakhs. Not like that. There may be a person who gets 35 lakhs also. There may be a person who gets 10 lakhs also at 5 years experience. Range is very wide actually. Okay. Even in PD, that's possible. Someone with 5 years experience could be getting 12 lakhs and could be getting 40 lakhs also. So that range. So you could be in the, if you are in the top bracket, you are earning well. Next, which has more prospects, front end or back end? As of today, our understanding is that front end has relatively better opportunities, relatively compared to back end. But things can change. Uh, but going by the today's scenario, we get more requirements for functional verification domain opportunities. What kind of tools are used in design and verification? See, design and verification, there are majorly four companies which provide the tools. One is Synopsys, Cadence, Enter or Siemens, Aldec. Some companies will be there. Another two, three companies will be there. Okay. The tools that are required for design and verification is majorly you need simulation and debug tools. Two types of tools. One is what? Simulation tool and debug tool. Every company provides those. It's like learning these tools is like learning a bike. Simple example. I learn Honda bike, for example. Then if I want to switch to Bajaj, it will take me 1 day, 1 or 2 days to learn those controls. Because gear, I have to learn how what is the gear mechanism, all that, right? It's the same thing. Once you learn mentor tool, for example, once you are expert in that, synopsis learning synopsis another 1 hour activity. Same thing for cadence. Because in Honda goes forward, Bajaj doesn't go backward, right? They have the same control. The way it happens is same. Just that little bit small changes will be there. That you can ramp up easily. As an institute, we have mentor tools, synopsis tools. We don't have cadence. We don't have Aldex. Aldex is not much used, but these are the two majorly used ones. You get access to these things. Synopsis, you get access to VCS, Verdi tools. Mentor, you get access to Questa. I mean, all Questa tools you can get. Questa, I mean, there are many other tools. Formal verification tools are there. Formal Pro you can do, but that's not really relevant. Formality, many tools. I told you, right? Both are simulation tools only. VCS is simulation tool. Just that the way the interface will be a bit different. That's all. The way the tool will look and all. Yeah, you'll be able. Both will provide the schematic tool. FPGA and DFT both are interrelated courses. No, they are no way related. They are completely different topics. I think I would answer DFT is about finding the manufacturing defects through set of techniques. FPGA is about one way of implementing the chip, developing the chip. Is that clear? The person who asked this question? Yeah. Means DFT is the actually in DFT what they do is if this is my chip, for example, it will have some flip flops. Some logic will be there. In DFT, there is one logic called as BIST is there, built-in self-test. What they do is they add some additional circuitry into the chip. They add some additional circuitry. Once you add, this becomes my entire chip. The built-in self-test. The testing logic is already part of your chip. That means if BIST is there, my phone has a BIST. My phone internally has it's a logic which can check itself. Built-in self-testing mechanism. So that need to be done at the RTL level only. When they are coding at that level only, they develop that the DFT engineer integrates this logic. There are few things they do once the synthesis is done. See, once they convert, they get flip flops. That they convert to scan flip flops. Because of that, DFT need to be done at front end level, RTL level also, at the gate level also, back end. Lab session schedule. Next question. Lab sessions happen every day. See, timings are generally 9:30 to 1:30 p.m. The theory goes for let's say 9:30 to 11 a.m. Labs will go from let's say 11:15 to 2 p.m. kind of time. Labs are not generally recorded. Theory will be recorded because see what is the purpose of lab is to support students with assignments. No, in that case you get the same support is available on weekends. Yes. Yes. Reason is, see, it's a support session. Support, there is no point of recording a support session. I go to a student, I see what is the issue he is facing. I cannot record his screen. I will only record my screen, so it doesn't help you much. Theory session is what I'm teaching. For example, you are not doing anything, I'm only driving entire thing, so this recording makes sense. But lab session, even if I record, you will be disturbed, more confused than anything.
How it will be in the online course like
Online, I can go here and make any student a presenter. For example, I can make Eindrilla a presenter. Once I make a presenter, her screen, I can even control her screen. See, there is a control here. I can control her screen. I can debug the issue, what she's facing. I can see the issue. I can suggest her and all that.
I mean, we can, I mean, once if you are attending from morning 9 to 2,
Yeah.
you can support through online on
Yes, yes,
laptop.
yes, yes, yes. The same time, this, for example, online student is also there offline.
Yes.
When offline student is required, I will go to him. When online student, I'll make him
You
presenter
will
and support.
support.
Yes. Yes, exactly. You can do. You can even stay in the institute till 8 p.m. and practice. The timings are not only limited to what is your class. The rooms will be available. You can just sit and practice. We wanted to have that kind of culture only in the institute. We didn't want to create a posh looking building. Simple, what is really required, that much only, and essentially keep the cost at a reasonable thing. When I can make it posh, another granite, lot of things I can do and increase the cost by another 10,000 doesn't help much. So, what is main focus is the learning should be focus, that we focus for sure. Next, I have a gap of 6 years. I was into UPSC. So, what is the prospects? Um, See, the answer for this question is a bit not straightforward. Um, Companies don't easily hire people with gap. Why they don't hire people with gap is lot of people are available in the market. When I need one person, if there are 10 people available, I can filter out. See, what company will say this person has gap of 6 years? I don't want, in simple terms, right? I mean, I'm trying to be very to the point, okay, rather than telling what is not there, okay. So there, okay, then there is a second opportunity where second type of companies, there you have chance. What is that is, there are many companies, around 20 plus companies, who hire people with gap only. Those companies don't hire freshers actually. They only hire people with gap. They train you, you learn the subject here, the company trains you, provides internal training to bring you on par with 2 to 3 years experience. Then they place you at the client projects. They show you as a 2 3 years experience person. The companies will show you as a 2 3 years experience person. Then they project. For freshers, they cannot do, right, because fresher means you passed out in 2023. How can they show 3 years experience? Okay. So there are companies who do that actually. Many companies do that because at the end they don't bother. I mean, they don't have any special thing like I should only hire fresher. They're open to hire anyone who is good, who can be placed in the project. Okay. Other thing is, like, companies are showing 2 3 experience for you. You do it yourself, get into job. What do I mean by that? You manage experience from somewhere, and you try as a 2 to 3 years experience, and you get a job. These are the possibilities. As a fresher, you don't get opportunity. Either you have to get into this kind of companies, or you have to do yourself, manage to get an experience, and with that experience you try and get it. Now, whether what you want to do, you can decide. I have told you what all options are available.
Sir, do you know the process to get that experience on our own?
No, no, experience means first you have to show your performance, then you get all the supports. Means once you join the course, you have to show your capability, then you get every possible support. You got the point what I said? Means only
Yes.
point is, whether it's a fresher, whether it's anyone, right? Simple thing, you show performance, you have a job. You have 20 years gap also, you will still get a job, you perform well. Okay.
Sir, you
What
were
is meant
talking
by
about
performance?
managing experience.
I know I said that also can be managed, but for that also you need to show the performance. Is that clear?
Yes, sir.
So what is meant by performance? Simple. 80 to 90% of assignments are you able to do yourself? We have a lot of assignments. 80 to 90% of the assignments by yourself can you do? Towards the end of the course, if I ask you any question from those assignments, are you able to do? You don't need to really do any research and development. I keep telling no innovation, nothing. What is taught in the class? Learn it properly and do it yourself. 7 8 months later, you have a job. Now, if you ask me why people don't get job here, they lose motivation many times. Initially, strength will be around 40. By the time we go to seventh month, strength will be 12 13. Now, do we teach in a not interesting manner? Not like that. We teach properly only. It's just that the kind of people who join, they don't have that motivation throughout. They join for different reasons. I don't want to squarely pass on the blame to student, but that's the fact we see always. I mean, the 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 same motivation level doesn't keep up till end of the course. So in summary, even if you have 6 years gap, you can still get a job. It's just about the initial starting salary may not be very good. You may have to manage with 3 lakhs 4 lakhs, but eventually when you perform, you will get a job, you will get a very good salary. Okay, I mean to say in this case also it's possible to get a job, but it's not binary like 1 or 0. You will get job or you won't get job. It's the performance is the criteria. If you perform well, you get a job. Which has better growth opportunities? Are those opportunities in India or out of India? Which has, I think I already told you, India. Yes, there are a lot of opportunities in India because what happens, uh, a good amount of VLS engineers are there in India actually, compared to US, compared to any other country. The number of resource available in India is good, and the quality is also relatively better. Quality is also relatively better. The thing is, let's say one of my friend went to US. He gets 2.5 lakhs dollars, which translates to probably 2.2 crores. The similar kind of work they can get it done here in 40 to 50 lakhs. The same person they could have hired here for 50 lakhs. So company doesn't bother, right, whether it's done in California or whether it's done in Bangalore, as long as the work is done. So that's why, and that's of course you know that that is the reason why all the jobs are here, right? Because of the cost difference. Same is in VLSI also. There are opportunities in India. If someone wants to move to US, they can move. There are opportunities where you can move from India to US also. Next, what tools are used in backend? See, it depends upon which domain you choose. Physical design means you use ICC2, prime time, design compiler, star RC, IC validator. If it is synthesis and STA course, we choose DC and prime time. Depending upon the domain which you choose, the tools will differ. If it is DFT, we use Mentor SN tool. This is the industry standard tool. Like no other institution uses this tool except our. I mean, we somehow got it luckily. Next, BTech is required to get into VLSI. BSc is not enough. BSc is not enough. With BSc, your chance of getting a job in VLSI is less than 1%. What are the prospects for experienced people in academic industry to move into VLSI? Uh, Prospects are good, and you should actively consider this. Reason is academic industry is not a, they don't respect the talent. Someone who is working in the college, a good faculty, at 10 years experience, they could still be getting 40 to 50K, maybe sometimes less than that also. Same person in the industry and get 40 to 50 lakhs per annum if he plans the career properly. I mean, this may be little too high, least 20 to 30 easily per month, of course. Now, why do companies hire is, I mean, my experience with faculty joining our institution has been very good. I mean, I would say 95% success rate. Why 95? More than 95% is generally someone who is already working in the academic domain, right? They are already good with the fundamentals. What is required to get a job in VLSI is the fundamentals only. No advanced topics. I told, right? No research, no innovation. Fundamentals should be good. If your fundamentals are good, second is they have already seen the hard part. I mean, getting a 40, 50K and managing a family is very difficult part. B, BTech freshers don't know that difficult part. I mean, you still haven't seen that part of the life, right? You only have seen the enjoyment part of the life. So you don't haven't seen. So you know only someone who has already worked for 3, 4 years at 20,000 rupees per month and manage the family knows the difficulty. What does it take to get a good job actually? So there you they those people who come from academic, they put that effort. They know the time, value of time and value of money and everything. Then they will eventually become successful. It's just the starting salary is the differing factor. Sometimes you may have 60,000 rupees salary per month. You may still have to start at 30K per month. That decisions you have to make. Except for that, very good chance that you get a job. Those who move from, let's say, someone working in college faculty, chances are very good. Can we change from software domain to VLSI? Possible. Only thing is, if you are, it's easy if you are already working in a company. Let's say you're working in Wipro, HCL, kind of companies. Let's say Capgemini. It's very easy because they already have related domains. They already have the VLSI domain. Let's say you are planning to move from JP Morgan, Wells Fargo. They don't have any VLSI. They are pure software companies. There you cannot convince. Except for that, it's possible. Again, if you are switching, yes, you can switch by your existing experience. It is possible, but the only point is about salary could be the different factor. Like right now, you may be drawing higher salary, you may have to start at lower salary. What are the hands-on projects done in the RTL design integration course? Mostly we work on a block called as DSI block integration. Uh, our main focus is not the complexity in the RTL design and integration. Main focus is not the complexity of what we do, but how deep we go into each aspect. Let's say we are doing linting. Are we talking about each aspect of the lint? Are we talking about every aspect of the clock domain processing? Are we talking about all the aspects of synthesis, SDC constraints, and everything? So we go deep into it. One is DSI, one will be student project. I think our trainer will have more information regarding that. Just address this.
In verification, which projects we do?
1 second, I'll take. Next, after completion of this course, can I change domain in my industry? Can I change domain in my industry? I mean, yes, you can change. Let's say you're working in, for example, physical design. You do course in DFT, you can switch to DFT. If that is the question you asked, it is possible. Because whatever course we do, you get the practical exposure, not just the theoretical exposure, practical exposure that enables you to work at 2 to 3 years experience level.
In this case,
Yeah.
if a person is working at post silicon,
Yeah.
can they move to the DD?
Sorry, they
Post
can move.
silicon.
In everything is possible. See, it's little bit you have to change your resume. Let's say you're working in post silicon validation. You cannot say that all 5 years I worked in post silicon validation. You should show that 3 years I worked into post silicon validation, 2 years into functional verification. Internally, I changed. So I'm trying as a, I want to switch the job. You should not be too honest. Little bit change should be done where some part into my previous domain. Now, why 2 years? Whatever expertise you gain in the course, you can show 2 years experience
This
even.
one, whatever we do this course,
Yeah.
we will be able to cover with that.
Yes, yes, that's why I said 2 3 years. I didn't say 6 years.
Yeah.
6 8 months you can show 2 years experience easily. When we are in online mode of training, how can we? Sorry, first let me answer. How can we use lab and tools? We have a VPN. See, even now I'm not in the server room. I'm not in the lab room. I mean, I'm working on my own laptop. We connect here. Actually, I'm already connected to server network, so I don't need to do VPN connection. But ideally, I'll have this kind of setup. I'll enter my password and all that. I connect. Then once I connect, you will have an application called as Putty. To that, you connect to the server. Connected. Then you start a VNC session. Let's say VNC session number 1. I went to VNC. 19 is the server name. 1 is the session number. Right? I went here. I'm showing you how your experience will be. Even when you do from your home, you will mostly have similar experience as long as your internet connection is good. Okay. Mentor. Let's say. Invoke the tool. I'm just showing you how this experience might run down. I'm just you got the idea, right? So things won't be slow. The way you are sitting at home, you can do the same thing what I'm doing. Okay. Now, if I have to support someone, all I need is this number. First thing, if I get this number, I can even though he has opened at his home, he's in Hyderabad. I can open the same thing here also because this number is same. Then I can support. One is that. This is how you do the labs. To support you further, I can make student a presenter and I see the screen and support them. The whole thing is possible. You got the idea, right? I hope this answers your question. How can we use the lab and tools? Through VPN, you will be able to connect to the server and practice the tools. You will have access to the entire set of tools which you can practice. Tools and the server will never become a blocking point for you. If we are an average performer in coding, then we are set for DV or not. See, what I will do is, what I will suggest is you start with DV. Try for 2 months. Like it, then continue or switch to other domain. Anyway, in this whole process, you lose only 1 month, right? That 1 month is also not a loss. You learn some new concept, new skill set. I have previously worked as a design verification engineer for 8 months. There, I had carried out assertion based verification. Then I took a break For past 1 year I had focused on government exams, so now which course will be better for me? One for freshers or experienced person? First thing, I don't suggest anyone to go for government exams. Oh, I mean, it's individual choice anyway. Many cases I've seen people who want to now switch from government job to private jobs after 5 6 years. Initial salaries will be high, 10 lakhs, 12 lakhs. After that it only grows 12, 13, 14, like that only grows. The promotions are very not, they're as per book rule book. After 4 years your salary will increment by 5%. After 10 years, after 7 8 years your promotion will happen to next level. Your performance don't have any value there actually. Politics has value but performance don't have any value there. Okay, so you, since you have already worked for 8 months, you can use that expertise and get into the industry.
How will you cover that 1 year?
No, no, see, I told you only one thing. If you are good with the subject, even if you have 20 years gap, 20 years gap, you still get a job, because the private sectors are there to hire skilled people who can do the job. That's all simple. Probably 20 years is a too much to say, but 1 year, 5 years, 10 years is not a big deal actually. People get jobs. The question is about your quality of learning. I told you, right, it's not a binary, you get job, you don't get job, not like that. Quality of preparation decides your chance of getting it. Next, yeah, you should go for a fresher course. This question is fresher course. Reason is you have been out of touch with the subject for 1 year or so, you would have lost touch. It's better to spend that additional 2 months and learn the things properly, then get into the industry. Because if you are already working, no need to start fresher course, but now you should definitely go fresher course. Go for fresher course. And government exams I don't suggest, because there's a too much competition actually. Whole North India focus only on government exams only. I mean, you are competing against whole of North Indian. I mean, no, nothing like South or North, but see, North Indian side mostly people are interested in government sector jobs only actually. So you compete against all that, and also you compete against the overall corruption in the government sector. Corruption means you don't know where the paper is getting leaked. Uh, right? There is always a lot of things actually. In private sector, it doesn't happen that way, right? It's all merit based. Weekdays, evening batches. See, I told you at least 5 6 people are required to start a weekend evening batch. For one or two, anything less than five, we won't do, because it has its own challenges to run a dedicated batch. If there are 5 6 people, we do. Even if you come with a list of 5 6 people, we are 5 6 people, conduct a evening batch, we'll do it. Next, what is the difference between online mode and offline mode? Um, what is the difference? Offline means you have a personal trainer directly interacting. Online means, right?
But the course wise it will be same.
It's same, no difference. Schedule, everything is same. Only thing is, in offline you have a trainer you're seeing directly. In online, sometimes I may turn on the camera, but it's you see the screen and you listen to the audio. There's no difference in schedule, content, placements, other projects or etc. Only difference is physically you're present in physical presence. That's all. Only physical presence in classroom. Okay. Which is better among training here or MS in VLSI domain? What is better is training, 2 years of job. Okay. With that, if you go, there is a good chance of getting a stipend. Otherwise, you will have to spend 40, 50 lakhs or 30 lakhs. Then there is no guarantee that you even get a job. Right? You will be in loan only. You'll be ending up paying in the loan only. Whereas when you go with training, 2 years job means the 2 years job experience will count. Once you are MS, once you complete MS, you don't try as a fresher there. You try as a 2+ years experience person. There you have a better chance of getting a job. Projects in BV. Yeah. What projects we do in BV is, these are all projects we do. Major project is Ethernet MAC verification. I mean, we keep changing this project, but see, it's not about how many we do; it's about the depth we do. It's done at a very depth. Actually, this project is done at very depth. Only thing is, students should have that capability to take that depth. Okay. Uh, then verification IP of development of AXI protocol, memory verification, RTL coding of synchronous asynchronous FIFO, SPI controller, interrupt controller, memory front door backdoor access concepts, the parallel in serial out. There are multiple things we do.
Interrupt controller will be with the UM also.
No, we don't teach with UVM. It is on Verilog, and maybe you can try with system Verilog. See, point is what? Once I teach this project and asynchronous FIFO with UVM, you should be able to do the third project. Means the what is expected in the job is one thing you are been taught, you have been told how to do. Second thing you should be able to do yourself. Yeah.
But when you talk about this interrupt, right? So it will become a you need some basic
No, that we
understanding.
teach, right? See,
Okay.
for that you don't need UVM to understand interrupt controller. You need the interrupt related concepts. So
Okay.
those concepts are all taught to you.
But to handle that same thing in the UM is a different.
No, no difference. UVM is a very simple concept. Once you learn the subject, you'll understand that it's a very simple thing. It actually makes the things easy. Let's say very long. It takes 6 months to do verification. System Verilog will make it only 4.5 months. UVM will make it 3.5 months. So once you know how to do in one project in UVM, second project you can easily do because it's the same process you have to follow. Okay, another last two questions. Let's take. Is there any pre-recorded videos available for design verification course? What is the difference between live course and pre-recorded videos? See, that is called as e-learning course. Pre-recorded videos is called as e-learning course. The e-learning course is very similar to live weekend course. Both are, I can say both of them are same. Okay. We don't just give the videos. We don't just go give the videos and ask go through. Many times people need guidance. Someone should be monitoring and asking what you have done, what support you need. So that is where we have live weekend course, where you get access to all the recorded videos for entire course duration. Every weekend, Saturday and Sunday, there will be a dedicated session. Trainer will be conducting for you. It's first thing. Other than that, in e-learning course, a dedicated mentor will be assigned. You can connect with the mentor anytime. You don't need to wait till Saturday and Sunday. Let's say you have a doubt on Monday, same day you post your question in the group. Okay, you get the support. For example, we have a group. Let's take randomly. I take this group. She has enrolled. We have created a group. Okay, she whatever support she needs, she gets the support here. Whatever support she needs, she gets all the support through this group.
For this, they will schedule a session and will.
Yeah, see, if it is a simple query, we address here itself.
If
If
it
it's a
is
simple query, we address here itself.
required, you can.
If required, we can have a dedicated session to cover those. I mean, a student who needs support, any support, let's say for example, he needs support, he posts support request here, the admin will address. So why we go for WhatsApp group is it's quick. Instead of mails will be slower, it can even 1 day 2 days delay, but WhatsApp is generally quick in response. In e-learning, first advantage is dedicated mentor will be there. The course material is exactly same. Other advantage is you can complete at your own pace. Let's say you want to finish it in 4 months, you can finish. If you want to finish it in 1 year, you can finish. I mean, based on your convenience, you can finish it in 4 months, 6 months, or 1 year also.
For that also you can come and hear daily.
Yes, yes, you can come.
But if you ask any doubts you have,
You can clarify. And other than that, live weekend sessions, I said. The course material also provided, course material hard copy provided. The placement support is same. Fees, some fees bit less compared to live training because you are not getting that live training every day, right? So the fee is relatively less compared to live training. Otherwise, you get all the other benefits.
and one more thing, like if somebody puts the line and if he completes 2 months after we place
It's
it,
possible.
after that he can get this e-learning.
Yeah. 2 months you join live training, you want to switch to e-learning, it's possible. You join e-learning, you want to switch to live training, it's possible. The policy is simple as long as it doesn't impact the institute. We don't. I'll tell you a few examples. I mean, where the arguments happen. One student joined in September, of course. He did digital Verilog. Okay, system Verilog probably started. No, not started. Now he comes and says refund. Only cut digital and refund whole remain. I say, how can I do? You've done Verilog. So there, except for that kind of things, I mean, maybe it's not relevant to the topic. Otherwise, we try to be very understanding from the student perspective only. I mean, as long as it doesn't impact. See, there I cannot only cut digital, right? I have to cut whatever he has done at least. Otherwise, if you ask me, I want to switch from e-learning to live. I don't have anything to lose there. Live training to e-learning, I don't have anything to lose. Right? For someone from academics, you suggest this course and any specific course. See, as I said, someone from academics. First of all, you have to choose which domain is right for you. Do you want to get into design verification? Do you want to get into physical design? Do you want to get into FPGA, DFT? Then you have to choose. Again, there you see the course content because academics means no common skill set, right? Different people have different skill set. You have to choose what is your current skill set, what is that we are teaching. You compare that and accordingly choose the course. There is no specific answer for this. I mean, you based on your current expertise you can choose. Let's say you're already good with digital and Verilog, very good with Verilog because you have taught that subject in engineering college. That means you can directly start with system Verilog. Let's say you are good with digital design, you skip digital and go to Verilog. So I hope it answers all the questions. Next, completion of 6 months online training, remaining months joining offline training. It is possible. I said right, that is called as hybrid model of training, where you can do 1 month online, 1 month offline, third month again online, fourth month offline. Everything is possible. Reason is schedule is same. Whatever schedule I am following for offline students, same schedule I follow for online. So I don't have any difference whether you attend online, whether you attend offline. Next is what if someone has 5 years gap. If someone has 5 years gap, so which one will be better for him to join, front end or back end? Again, I told you, probably it's better to join back end only in this case. Reason is front end means 5 years gap means you would have lost entire touch with the coding. If at all you have done any C programming before, you would have lost entire touch, right? So you, for you again starting off with the coding will be difficult. So it is better to do backend domain. In that also you can go for either DFT or you can even choose FPGA kind of domains. These are relatively easy to learn and ramp. Generally, anyone having gap, DFT or FPGA could be a better domains. Because in DFT, the advantage is you don't need to learn semiconductors. It's just set of techniques. You need to learn what is meant by scan technique, ATPG, BIST, and you don't even need coding expertise. The problem with physical design is you again need to learn what is fabrication, what is semiconductors, what is MOSFET. That knowledge is not required for DFT. Any other questions?
So if you are having experience in FPGA,
Yeah.
there is a job vacancy in ASIC. Can we shift or should we learn any course?
You should learn at least system Verilog. To switch to ASIC, you should be good with system Verilog. Even if you don't know UVM properly, SV should be good. Then you can switch from FPGA to ASIC.
Can we same experience we can shift, sir, or extra course we should learn?
No, that's what. See, same course, you have to do additionally system Verilog course. System Verilog, maybe one project. That will be. Any other questions? But my suggestion is if you decided FPGA, better to pursue everything in FPGA only. Because I mean, even though I said only answer is system Verilog, then it may happen that company may ask, have you done UVM? Have you done project? Okay, so because company has different requirements, which I cannot say this is what the rule is. Not every topic. So I will be handling some of the topics. Then other trainers also there, they will also be handling. Reason is there are, let's say, 4 5 batches running parallelly, for example. We cannot, one trainer cannot do everything.
But for if you have any question, we can.
Yeah, we can always connect with me, and not that other trainers are not good. They are all very good. Yeah. Okay, yes.
No, what will happen is like if you try to attend some interviews,
Yeah.
so there will be some questions you have not come across not yet.
Yeah.
So that question we can come and produce with you. So we'll be
Yeah,
able
we
to.
can discuss. Yes. Can you give any surety about placements? Uh, uh, no surety, no 100% guarantee. Only guarantee I can give is you do 90% of assignments, course assignments. I'll give 100% guarantee. That will be better step. You do 90% of the course assignments, I'll give you 100% job. 100%. If company also don't give, I'll give the job. Why this confidence is, once you do 90% of the assignments, you have your confidence in your skill set. You don't depend on someone else to give you a job. You know that you can get a job. That is the role of an institution. Institution role is not to give a job offer letter to you. Institution role is to fill that gap where you come to a level where you know that you have enough skill set to fit into the industry requirements. Okay. But this line is not a joke. I'm not making a joke or anything. You do 90% assignment, I give you job 100%. Again, you don't need to do anything. I mean, these are not anything new. What is taught in the class, every topic is taught in the class. All these assignments are taught by the trainer. You just have to complete those. Then you may say, why everyone doesn't get job? Lack of motivation. Someone who didn't had motivation for 22 years of their BTech, I cannot bring that motivation in 6 months. There are few things comes with childhood, right? What's the difference between what is difference in Verilog SV for design and for verification? See, design requires only synthesizable constructs. There are specific set of constructs only will be suitable. Verification, any language construct can be used. For verification, any language construct can be used. So Verilog and system Verilog also has mix of those constructs. Some constructs, some language constructs, which are only suitable for design. Then other which are suitable for verification. Difference means that's the difference. I mean, this is, as we go into the language, we will understand the difference further. Now, if you talk about system Verilog, it has more features than Verilog. So system Verilog provides more options. Tell me whether C provides more options or C++. C++. Same with Verilog and SV. Like Verilog, system Verilog. System Verilog has more things compared to Verilog. In case of custom layout, what will be learning? In case of custom layout, what we will be teaching? We'll be teaching all the layout fundamentals. Basically, we'll be having 2 months of basics training covering 2 to 2.5 months, 2.5 months basics training covering all the fundamentals like digital design, the semiconductors, fabrication, layout, network theory, everything, fundamentals. Because see, always getting a job, fundamentals are very, very important. Then 4 months of training on analog layout, standard cell layout, IO and memory layout. These things with multiple hands-on projects. Uh, I am in e-learning flexible course. Can I join course some weekdays? If yes, will I get link every day? No, you don't get the link because you have to choose whether you want to go to e-learning or live training. If you want to both, let's say e-learning plus live course, there will be some additional charge, right? Uh, Either you choose live training, either you choose e-learning. If you want both, there will be some cost, 25%, some additional cost will be there. Then you get both of that. But if you join live training, you don't need e-learning because you get access to every video for 2 weeks, which you can watch at your own convenience. So this is all about. Any other questions? Okay. Thank you everyone for attending the session. In case you want to enroll, the course would be starting from Monday onwards. That is 22nd of Jan. The course will commence. We will be for 2 3 days. We'll be teaching GVIM fundamentals. Because what happens Monday, Tuesday, Wednesday, few people enroll still. Wednesday or Thursday onwards, the actual course content will start. I mean, doesn't mean that Monday or Tuesday is useless. They are very useful. GVIM, what you learn is useful. The digital design will start from Wednesday onwards. Those who in case happen to miss, GVIM gets repeated at some other time. Okay. But my suggestion is better to join by Monday so that you are in sync with the flow. Uh, you can confirm your enrollment by paying 5K. Remaining things you can talk to the team and get the details. Okay. This is about it. Any other questions? Uh, Someone was asking regarding placements. Placements have been good in last 2 months. I mean, good in doesn't mean that all 100%. I would say somewhere around 30 40% right now gets placed. Um, in current market, even 30 40% is a good number. Now, you may say, what happens to remaining 60 70%? They learn after a few months, they get jobs. It's about your preparation level, is what decides. Any other questions? We will end the session. Can you provide detailed topics in our training? You can go to, please go to this link, you get the entire details. You go to this topic, let's say in functional verification course, you go to the syllabus, you get what is the duration, what is done in digital design, in depth, each and every slide, Verilog, what we teach, Verilog projects, what we teach, system Verilog language, what we teach. Okay, everything is explained, including the project, what we do, everything is there. You please go through this link. You can get this link from our website. Any other questions? Uh, this is my number. Okay. Yeah, any other questions? Okay, fine, we will end this session. Thank you everyone.